Vai pure. Vai pure, Lorenzo.
Okay. Good morning. Welcome to everybody. This is our second day for this conference on the future of forecasting and nowcasting. My name is Lorenzo Forni. I'm the head of Prometheus Associazione, that actually is co-organizing, sponsoring and co-organizing this event together with Professor Giuseppe Cavaliere of the University of Bologna. We are in the auditorium of the headquarters of the Prometheus Group in Bologna, and this is an hybrid event. I think you should have the program, but let me remind you briefly how the day or the morning is going to go. We will start with Professor Massimiliano Marcellino right away, and then so we will have talk of about 45 minutes each, including questions. And next, it will come Francesco Ravazzolo from the University of Bolzano, and then Monica Billio from the University of Venice. And this will, end the first part, and then we'll conclude from about 11:30 to 12:30, at least Italian time, with a panel discussion with Roberto Golinelli, Luca Fanelli, Andrea Carriero, and this all from the University of Bologna. And this panel will be moderated by Professor Giuseppe Cavaliere. Okay, 4 questions from home or from office. If you're online, you have 2 options. One is just to raise your little yellow hand, and we'll give you the mic. Or you can write the question in the Q&A section, and we'll read it out when we get it. I think I've said everything. I will leave the floor to Massimiliano Marcellino. Actually, let me really thank all the speakers and the people have decided to contribute to this conference. I didn't go over again, regarding the reasons why we decided to organize this conference, but I think it should be rather evident that after all the shocks that we have been going through, our profession needs, some pause and thinking how to move forward on forecasting and nowcasting. Massimiliano, the floor is yours. Let me know. You can start with your slide. Thank you so much.
Okay, so thanks a lot, Lorenzo, to you and Giuseppe and to Prometheus for organizing this very interesting conference. And again, pity I cannot be there with you, but hopefully there will be other occasions very soon. And indeed, it's a very timely event, given all the issues and problems that there have been for economic forecasting and nowcasting related to COVID, but not only. And so what I would like to do is give a kind of overview of the kind of problems that we have seen and faced and of possible solutions, and then to discuss how the use of mixed frequency, new and large data set can at least in part hopefully address the issues that we have seen. And basically, of course, the interest in forecast and in nowcast, so in predicting the present, for example, GDP growth in the second quarter before it's released, is increasing the value of these in uncertain times. And so there is quite a lot of interest in forecasts and in economic forecasts during recessions like the financial crisis, as we have seen now during the COVID pandemic or with the Ukraine war, or in general when there are extreme events like the terrorist attack of 9/11 in the United States and so on. And a little bit the problem is that exactly when attention is focused on us as forecasters, typically this is the problem, that this is the time when our forecasts are particularly bad and imprecise. And so the risk we face is that basically we fail with our forecast. We make large forecast errors exactly when everyone is looking at us. And so for this reason, it would be even more important to try to improve the accuracy of our forecast when we are in uncertain times. And so for this, it can be interesting to study and to try to understand what are the reasons for the failure of our models, in particular in the presence of these extreme events. And so here I've tried to write down what I think are the main reasons for failure. And so the first issue is that a lot of our econometric models focus on the conditional mean. And instead, extreme events are basically by definition events that are away from the mean. And so what I mean, if we have a very simple graph, for example, of a variable like GDP growth and we graph it over time, is that, we will have our business cycle fluctuations, so events like this. And so as long as GDP growth is along the average, our model that is basically typically trying to explain and predict the expected value of y given x linearly, our model will be really pretty accurate when we are with average growth, while the accuracy of the model will more or less by necessity decrease exactly when we are in situations where we are far away from the conditional mean of the variable that we are interested in monitoring. So this is a kind of statistical reason, and then we will see what we can do about it. And a second possibility and reason for failure during crisis time is that we tend to estimate our models by ordinary least squares. And so when we try to construct forecasts, basically we replace the beta, so the unknown parameters in the linear regression model, with a beta with a hat, where this beta with a hat is the OLS estimator for the unknown parameter beta. And the problem, as you are aware, is that ordinary least squares is an optimal estimator under general circumstances, but it is very sensitive to outliers. And so if you are in a situation like the red dots here, in particular, when you have something like a big crisis like the financial crisis or the COVID pandemic, OLS, to try to minimize the model error in coincidence with these very large observations, basically will introduce a bias in the model parameters. And so again, this at the point can contribute to forecast failure, in a sense that we are not looking at the correct reaction of, say, GDP growth to the explanatory variables that we are using in the model. A third reason, a little bit connected to the second one, is that in our models, typically we assume that the parameters remain stable over time. And so, we assume that, as we have written there, the expected value of y given x remains xt beta, if you wish, during the whole period. But instead, it could be that this beta is not really stable, but maybe we should put a t, an index t, also associated with beta, to capture the fact that the relationship between GDP growth and the variables that we use either to explain it or to predict it can be changing over time itself. And of course, if beta is changing, for example, if leading indicators have a different relationship with the target variable during expansions and during recessions, and instead we assume that beta is constant, we will make forecast errors. And these errors will be particularly large exactly when beta is changing. So for example, when we are entering a big recession like the one associated with the COVID pandemic. And similarly, it could be that the relationship not only is time varying, but it could also become nonlinear. And so it could be that this expected value of y given x is not an xt beta, but it could be instead a generic function f of our explanatory variables. And then again, we could think of approximating this f function with basis expansion. So for example, using interacting terms and so on. But again, this could be another reason that, this linearity becomes particularly relevant in the presence of extreme events, And again, by instead using linear models, we can get bad forecast in those situations. And yet another reason for failure of our nowcast and forecast, in particular in problematic times, is that often we work with, let's say, standard economic indicators. So, for example, we use industrial production to monitor the evolution of GDP growth. And these standard indicators can be released with a delay. And so the fact that they are not so timely can contribute to giving us at least a blurred and imprecise view of what is going on. And so the idea would be to try to do something to address, at least in part, these four main reasons for forecast failures when there are extreme events like the COVID pandemic, and see whether we can do any better by working with extended models. And so thinking about, again, possible remedies, if we start with the first issue, so most econometric models focus on conditional means, but extreme events are by definition away from the mean. One possibility could be, if we think of the picture in the previous slide, so if we think of this situation here, one possibility could be to construct models that are specifically meant for capturing different quantiles of the distribution of our target variables. So we could have a separate model to explain situations when GDP growth is very large or very high, a different model for when GDP growth is close to the median values, yet another model for when GDP growth is pretty low, and possibly even a different model for when GDP growth really takes extreme values. And so for this, one possibility is to move from the linear regression model to quantile regressions, and so try to explain the different quantiles of GDP growth or inflation or unemployment rather than focusing only on the conditional expectation. And this kind of literature, as you may be aware, is kind of booming recently. It started more or less with this nice paper by Giulio, Kelly, and Prout on modeling the tails, and it has been popularized even more by the paper by Adrian Boyarchenko and Giannone in the American Economic Review that basically links tail risks to output to financial conditions with a special focus on what happened during the financial crisis. And then similar techniques to try to predict and monitor extreme events, not only for GDP growth, have been also used for inflation and for unemployment. And in general, there is a nice paper in JBS, for example, by Manzan, showing that quantile regression can indeed be used to assess the value also of large information sets in forecasting. And so in forecasting, not only the expected value, but the entire distribution of some key variables like GDP growth, inflation, unemployment, and whatever. Okay. So in this area, we have done some work with Andrea Carriero, who is there with you, and with Todd Clark. And so in particular, we were wondering whether you really need to use these quantile methods, or you can still keep using some of the models that we are familiar with, like vector autoregressive models, possibly their Bayesian version that allows you to handle pretty large information set, but complement them with changing variances, so with stochastic volatility. And it turns out that this is a kind of convenient trick, the fact of having stochastic volatility, because the idea is that, say, when you are during normal times, for example, for GDP growth, you have a distribution for GDP growth that maybe looks like something like that, while when you are in crisis time, you get two effects. The first one is that the distribution is shifted to the left, but the second one is that it also becomes much more, let's say, distributed across the axis. So uncertainty basically increases quite a lot. And so what you can show is that this combination of changes in mean and in variance can actually replicate the kind of behavior of quantile regression and can explain the fact that the behavior in the tails of the distribution can be different when you are in normal times and when you are in problematic times, okay? And so this is in this paper with Andrea and Todd. And then we have a second paper that is something that, again, if we have time, I will show you a little bit in more details on instead working with quantile regression, so replicating this previous analysis like Adrian et al., but working with Bayesian version of quantile regression and a variety of these Bayesian quantile regressions that also allow you to handle large and mixed frequency data sets as a way to further improve the performance of the model during problematic times, okay? Now, how about the second possible reason for failure of our forecast during extreme periods? Again, you remember this could be related with the method of estimation, so OLS that is pretty sensitive to outliers, again combined with the fact that when we are in problematic times, outliers take place quite often. And so here again, you can think of alternative possibilities to try to reduce the impact of the extreme observations on parameter estimation and so also on the forecast. And so specifically for the COVID period, one very simple suggestion by Shorefire and Song, for example, is to completely drop the COVID observations when you estimate VAR parameters. And so, for example, you would estimate, say, 2022, and you would forecast 2022 and 2023 using information only up to 2019. And so if you wish, this is pretty similar to inserting dummy variables into your model. And indeed, in some work, again, with Andrea and with Todd and with Elmar Mertens at the Bundesbank, we showed that at least for the United States and for several variables, if you are interested in just constructing a point forecast or for nowcast for several economic variables, dummy variables for the COVID observations do help you quite a lot. So you can get a substantial reduction in the mean squared error, in the forecast mean squared error, by adding dummy variables for the COVID observations. But of course, this is not the optimal solution because basically you are treating these extreme events as known and deterministic. And so you substantially underestimate the uncertainty in the system that leads you to having biased interval and density forecast. So what else could we do if we are not satisfied with just using dummy variables? And so here again, there is a variety of approaches that can be taken and that could help. One possibility that is pretty common, in particular in institutions like central banks, is basically to introduce some ad hoc adjustment to the forecast, for example, using intercept corrections. And on this, we have done some work with Claudia Forni and Dalibor Stevanovic, where basically the idea is to adjust in real time the nowcast for the COVID period by an amount that is similar to the corresponding errors that were made during the financial crisis. And of course, we know that, you know, both the source and the propagation mechanism were very different during the COVID period and during the financial crisis. But it turns out that still, if you make this kind of ad hoc adjustment, you get a substantial improvement in the nowcast and you get a substantial reduction in the bias of the nowcast, again, at least in the case of the United States, but also for several other G7 countries. So this could be, you know, a kind of ad hoc adjustment. And then again, in this case, we do it by looking at another previous problematic period with another major drop in real activity. You could do it judgmentally as well, and it could still work. Now, another possibility is instead to somehow change the estimation method. And so when we do OLS, I mean, if you think about it, in a case of the OLS estimator, what we do is we work with estimates of variances and covariances of the random variables. And we estimate these variances and covariances by taking simple averages of the moments, okay? So what you could do is instead you could take weighted averages. So for example, imagine that you have a single explanatory variable. So rather than working with the sum of xt yt divided by the sum of xt squared here, what you could do is you could put some weights. So you could put an omega t in here, and you could put an omega t down here. And so you could construct estimators where observations have different weights. So how can you choose these weights? Again, you can choose them such that you overweight periods that were similar to the current problematic period that you are in. So again, thinking of COVID and thinking of the financial crisis, the idea is that you could overweight the financial crisis observations and correspondingly downweight, say, periods of high growth when you are specifically interested in estimating and forecasting during the COVID period. And this is pretty similar to a technique that is used in now what is called machine learning, and it's basically nearest neighborhood. And so the idea again of overemphasizing the importance of observations that are in a neighborhood of the current period, okay? And so again, we have experimented with these in a paper with Yannis Dandramis and George Kapetanius. And indeed, it turns out that this similarity-based estimation helps during COVID, but at least in our experience, it is not as good as intercept corrections, most likely because the kind of weights that you are using are not so extreme as the kind of adjustment of the forecast that instead you make when you work with intercept correction, okay? Now, again, you see that there is quite a lot that can be done and tried already. One other possibility is to downweight the outliers. So when you put dummies, you completely get rid of the outliers, so you treat them as deterministic. When you do similarity-based estimation, in a sense, you are increasing the weight of similar observations. With this approach introduced in this paper by Lenz and Primiceri, rather than increasing the weight of similar observations, you decrease instead the weight of the problematic observations, and so in this case of the outliers, okay? And how can you do this in practice? You can do it by working with specific models of stochastic volatility, as I briefly mentioned before. So stochastic volatility is basically a situation where you allow the variance of your error term. So you allow the variance of your epsilon t to be changing over time, and so typically to be increasing during recessionary periods. And again, if you think of the simplest generalized least square estimators to handle this kind of heteroscedasticity, what your GLS estimator is doing is basically exactly downweighting observations that are associated with periods of large sigma square t. So the idea is related to the informativeness of the data that you get. So if the data are not so informative because they are associated with period where sigma square is very large, you want to downweight them. And in a sense, this gives you optimal estimators. So if you push this kind of intuition to the limit, you can even completely get rid of outliers. And so we further extend this analysis in a paper that is again with Andrea and with Todd and with Elmar Mertens. And basically we show you that if you work with models where you have both stochastic volatility and you also have t-student distributed errors rather than Gaussian errors, which is what we call stochastic volatility augmented for outliers and t-distributed errors, this kind of thing is the kind of methodology that works best to produce not only the best point forecast and nowcast during the COVID period, but also properly calibrated interval and density forecasts. Okay, and so this is more or less about estimation and outliers. So what else is happening? Again, as we said, another possible issue is that instead you could have unstable parameters, or you could have nonlinear relationships, and this kind of feature can become particularly problematic during periods like the COVID pandemic or the financial crisis or the Ukraine war. So when you have sudden, very important shocks. So what can you do to handle these kind of issues? Of course, you can adopt a variety of parametric specifications that have been developed over time in the literature. So for example, you can work with threshold models, with smooth transition models, with Markov switching models, and so on. And you can include all of these features either in small models like autoregressive and VARs, or in large models, and both in the single and in the mixed frequency context. Now, one issue is that theoretically, these kind of sophisticated econometric models are extremely nice, but when you apply them for day-by-day work, it's kind of pretty difficult to find a single best performing specification that works well, let's say, over a prolonged period of time and for different economic variables. So we did a pretty large evaluation of all these alternative models that are mentioned in the previous bullet point, so like those, in a paper with Laurent Ferrara and Matteo Mogliani at the time at Banque de France for the financial crisis. And again, we found in line with previous results that were for more general episodes, that even during the financial crisis, these more sophisticated parametric models with time variation can help you, but the results are pretty heterogeneous. So something a little bit newer and perhaps more promising is rather than taking a parametric approach, and so, you know, assuming Markov switching or assuming threshold, could be to work with non-parametric time variation. So just hypothesizing that your parameters change and then making some kind of smoothness and possibly continuity assumptions on the evolution of beta t, but without requiring a particular specification on the evolution of beta t. And then at that point, you use a kernel-based estimation to try to uncover period by period the evolution of your parameters, and then you use this time-varying framework also to construct forecast and nowcast. And George Capetanios did a lot of work in this area, and we have a joint paper with him and with Fabrizio Venditti at the Bank of Italy, showing that you can apply this non-parametric machinery also for very large models, so for models with like 60 or 70 variables, if you combine them with shrinkage. And so shrinkage, you can do it either in a Bayesian world by using proper priors, but you can also do it in a classical context using stochastic constraints, okay? And so, you know, this is, again, one possibility that can help you. And then coming to yet the other possible reason for forecast failures is the fact that often our econometric models and forecasting models rely on a few selected economic indicators. And again, in general, this is a good idea because we know that parsimony pays off. It's good. But when you have this kind of shocking events, so very large outliers hitting the system or large shocks hitting the system, you should instead try to collect information also from a variety of other indicators. And indeed, typically what you find, for example, in the literature on dynamic model averaging is that during crisis time, you should work with large models, and during tranquil periods, you can work instead with smaller models. And so the idea is that then in our models, we would also like to include these large information sets And this you can do it again either with factor models or with large Bayesian VARs, either in single frequency or even mixed frequency if you want to include even more timely information. And in this sense, something that I think has not yet reached the general, let's say, forecasting community is the fact that you can do even better by specifically targeting the summary of this large information set toward the variables that you are interested in. And so this you can do it in the context of factor models working with this 3-pass regression filter or its mixed frequency version, but you can also do it with quantile regression with a method that was proposed by Giulio, Kelly, and Krut that is called partial quantile regressions, where basically you summarize this large information set, making them specifically suited to construct quantile forecasts for each percentile, for example, of GDP growth or of inflation and so on. Okay. Now, something else that has become, as you know, and as was also discussed in other presentations of this nice conference, is that machine learning methods are becoming also pretty popular in the macroeconomic and financial forecasting literature. And so here there is a kind of dichotomy between traditional models like factor models and VARs that basically assume a dense data structure where each variable depends on all the other variables. And instead, the machine learning methods, and at least most of them, instead assume a pretty sparse structure. And so the usual game in machine learning is that you have millions of possible predictors and you have to try to identify the few ones that are really significant within, for example, very sparse and very large variance-covariance matrices. So given these kind of dichotomy between dense and sparse as a starting point for traditional large econometric models and machine learning, there is an issue, an empirical issue of whether machine learning techniques are empirically useful for nowcasting or forecasting. And so in this context, again, classical machine learning methods have been found to perform reasonably well compared with factor models or large Bayesian VARs in papers such as the macroeconomic random forest of Goulet-Coulomb or the JBS paper by Mederius and co-authors on forecasting inflation. And we have applied similar machinery in a paper with Goulet-Coulomb and Stevanovic, and we have found that indeed some of these machine learning methods would have done a good job during COVID, better than factor models, and random forests seem to be particularly useful in this context. Okay. And so something else that I have been working on really recently is on basically Bayesian non-parametric statistics that involves a set of techniques that are used in the Bayesian version of machine learning. And so, for example, the Bayesian version of the random forest or of boosted trees is called Bayesian additive regression trees. And this has been shown to work very nicely in a paper by Huber and co-authors for nowcasting, and this is a paper in the Journal of Econometrics. And now we have a couple of papers working with these Bayesian additive regression trees. Again, this is joint work with Florian Huber, Todd Clark, Gary Koop, and a set of other co-authors in there. Okay. And so this is something else that, again, possibly is promising in the sense that these techniques should allow you more or less in real time to select kind of automatically what are the most relevant indicators and should be, again, capable more or less in real time also to give you the possibility of having changes in the relationship between your target variable y and the set of predictors that you want to get. Okay. And then something else to conclude this kind of general survey of what you could do to handle these problematic situations like COVID or crisis or wars is based instead more on the data themselves. And so there is a lot of recent interesting literature on the use of alternative indicators. So for example, Google Trends or web scrape data, mobility data, credit card transactions, scanner prices, and text-based indicators. So you may remember, for example, the very nice presentation by Yuri Marcucci in the previous half-day workshop on the use of Twitter data for predicting inflation and GDP growth, or the presentation by Promethea, who is also experimenting with this alternative data. So this is all stuff that indeed is pretty nice. And actually, at the moment, we are working with Google Trends to predict inflation in the United States, and that seems to give pretty good results. On the other hand, I think this is a very interesting way forward, so the use of these alternative indicators, but you have to handle them with care, because often there are data quality issues. So the samples are short, there can be very weird seasonal or temporal patterns, there are structuring issues. For example, how do you move from textual data to sentiment indicators? And you know, typically what you see is the result of a variety of experimentations. And so the result is an indicator that works, but typically it is tailored quite a lot on a specific application. So who knows whether that technique will have a general applicability or not. And another thing is that often in this literature, in particular in machine learning, or when people suggest new indicators, often these new indicators are considered in isolation rather than in addition to more standard indicators. And again, if you go back to Yuri's paper, he shows that these Twitter data are actually relevant in addition to other standard predictors for inflation. And that is the kind of analysis that we should do to really evaluate whether these indicators are useful or not. And of course, many of these during the COVID period in particular turned out to be pretty relevant, in particular credit card transaction data or Google mobility data to track the evolution of the economy. And so again, I have more or less finished my time. So since I'm always optimistic, I put a lot of more slides. And basically the paper that I wanted to show you, just to give you an overview, is a paper that tries to put together a lot of these issues that I have discussed. So it's a paper where we work with large data sets, with mixed frequencies, with alternative indicators, and we focus on forecasts and nowcasts for the tails. And so it is this paper that is called Nowcasting Tail Risks to Economic Activity with Many Indicators, and it is joint work with Andrea and Todd. And again, just to give you an overview of what we do in this model, is basically we try to focus on nowcast of tail risks to GDP growth in this specific paper. And we work with a variety of alternative methods. And also we work with pretty high frequency updating of these nowcasts of tail risks with basically weekly updating of the forecast. And we consider a pretty large set of monthly, weekly, and also some daily indicators that then we aggregate at the weekly level. And we use blocking as a way to treat mixed frequencies combined with Bayesian estimation to keep under control the parameter proliferation. And so in the paper, as you will see, if you have time and you want to look at the slides, we consider a variety of techniques to handle these large mixed frequency alternative data to predict specifically the tails. And so one of the techniques is Bayesian shrinkage, but applied in the context of quantile regression models. Another possibility are data reduction techniques, so either factors or targeted factors, but again applied in the context of quantile models, or combination of quantile forecasts. And all of this is done either in a classical context where typically you do shrinkage by adding a lasso or a ridge or an elastic net penalization to the to the target function, or directly with Bayesian techniques again. And then we also compare the performance of these specific quantile models with what you would get with the Bayesian models that we have briefly seen before. And I think I would stop here. Then again, for those of you who may be interested, there is much more about this paper in the coming slides. Thank you very much.
Massimiliano, thank you so much. There was a lot of material that you presented, so let me open up for questions. We have a few minutes. So who wants to go first? Okay, so I'm going to go first. So you mentioned the Bayesian additive regression trees. Sorry. That's okay. I was wondering, can you expand a little bit more on what variable you were targeting, with which frequency, and just a little bit more, what do you think was good for?
Oh, thanks, Lorenzo. So this is pretty interesting. So basically, we are experimenting with 3 types of Bayesian techniques. Indeed, one is this Bayesian additive regression trees. Another one is Gaussian processes. And the third one is the Bayesian version of neural networks, but some specific types of these. So with the Bayesian additive regression trees, there is this paper by Florian Huber, Gary Koop, and co-authors that basically apply it to nowcasting GDP growth with a pretty large information set. And so we were interested in replicating their analysis, but focusing specifically on tail events. So situation where GDP growth is either very high or very low. And in addition to looking at GDP growth, we also look at inflation, thinking of situations of deflation that are pretty scary for central banks, but thinking also of what is happening now with this massive increase in inflation that we are seeing in many countries. And then we have also experimented with these BART models for unemployment, where again, in particular, in the case of unemployment, the right tail, so massive increases in unemployment, like those that we experienced, for example, in the United States at the beginning of the pandemic, can become particularly problematic. But also the current situation in the United States, where instead unemployment is in the left tail, is putting so much pressure into the labor market that it's also problematic. And so these are very flexible models that can handle pretty efficiently very large information sets. So typically we work in these papers with all the indicators in the McCracken and Inge database. So we have about 130, 140 indicators, and you can also add transformations of them. So without any major problem. And again, it's always an issue of relative performance versus absolute performance, in the sense that if you compare this machinery, these BART models with quantile regressions or even Bayesian quantile regressions and so on, they are doing a pretty good job in relative terms, but still in absolute terms, they can still have problems in capturing for example, the massive drops that was experienced in GDP growth, or the massive increase in unemployment in a lot of countries during the pandemic. And then instead, with Gaussian processes, what you can do is you can approximate nonlinear relationships across variables. So they're a kind of general approximator, a bit like neural networks. And so on Gaussian processes, we have another paper again with Gary Koop and Andrea, and this with Todd and with Florian Huber on forecasting inflation. And it seems to be working even better than BART, in the sense that somehow the model is even more reactive than BART when the dynamics of inflation start changing dramatically, like we are seeing in these last more or less 12 or 12 months or so for inflation. So again, it's promising. It's something that we need to experiment with a little bit more, I think, before putting them, say, into the production process. But it's something that also several central banks are kind of experimenting with, possibly in combination with this alternative data, like on credit cards, for example, that seem to be extremely useful for consumption and GDP growth, or with scanner price data and web scrape price data for inflation.
Massimiliano, thank you so much. Our time is up. There was a lot of material, so this was super useful. Maybe too much stuff.
Indeed. Thank you.
So you should work a little bit less, I guess.
Yes.
Anyway, thank you so much for joining.
Thank you. Bye-bye.
And see you soon. So let me now give the floor to Francesco Ravazzolo. You will introduce your talk, and you can move your slides from here.
Thank you, Lorenzo. So let me first thank both Lorenzo, Giuseppe, all of you to be here. It's my first time here. I was thinking, despite that I know you, so part of my students, which we were with Monica, came to work at the microphones, otherwise you cannot hear me from home. Came to work here, so some did the thesis and my time master thesis at the time of the laurea, obviously. So I'm very happy to be here. And also to give me the chance to talk about this topic, which, you know, I had to think, as you can see, I have a lot of affiliations here, and I will explain why they are useful for this talk. So I spend 1 second to introduce that. And I was flying to Norway often recently, and it took me 3 or 4 flights to think of what to present here. And as Lorenzo was saying, my main affiliation is, and I'm not good with the microphone today. My main affiliation is Bolzano, but at the moment I'm also back in Norway part-time. And then there is a first affiliation, which is called Aqua, which is a spin-off on artificial intelligence, on Aqua. So basically, in the last 10 years, I thought about this. So I was living in Norway when I started to think about that. And I was looking in Norway, and I was thinking, why there is not a macro model, which is very good in modeling the energy sector, and then taking this information in what, for example, at that time the central bank was doing. And Norway is an interesting case because 20% of the GDP is straightforward gas and oil, plus the electricity is 94, 96% hydro. They made the market, the Nord Pool, 30 years ago, 35 years ago. So I thought, why not? And even there were just a couple of people which now have retired. One was the former governor of Central Bank, which has just retired. Maybe you know more Mark, which was studying together with Hamilton, if someone of you has learned. And of course, one of my promoters there, Bjornand, has worked on this type of topics, but very few people were doing work on this type of approach. Then I came back here. Here was even funnier in one way, because I remember our politicians were going to Russia or Saudi Arabia to learn how to manage wealth, commodities wealth. None of them was going to Norway at the time, or probably someone went in 2010 and they were heavily criticized about that. And I thought, okay, there must be something that I'm not able to understand. So let's see how I try to handle this and maybe to give some inspiration to you. And my view is the following one. Energy markets are becoming more and more important, but they are difficult to understand. And we as economists, at least as an economist, we fought it just in one series at the beginning, which was oil. And the reason is because oil we use in many things. It's easy to understand who is producing oil. There are a few countries producing, all the others. Depending on that, oil is a relatively easy asset, commodity to manage. It can be stored. Even ourselves could buy a boat and store there. Someone did, maybe not a boat, but a barrel at least. And investment banks went heavy on this argument. And we learn from there, and we start to think in that direction. And I will say that most of our literature as driven by these elements. But then what happened? In the late 90s, I would say Europe slightly later, two important markets, electricity and gas, started to be deregulated. First was the electricity, then the gas. The gas is recently, last 15 years, that they are not linked to the oil. So if you go to a gas producer, usually the price they used to do, it was a percentage of the oil. So oil was moving, gas was moving on the same way. That was typical of what the Russians were doing with long contracts, but even Norwegians did the same. But now what is happening? Now there are at least two things which I find important. One, we have realized that maybe we are polluting a bit too much and pushing the transition of the global warming. I'm not entering, of course, in that topic, but there is a concern of now about that element. So we think it will be more important to keep an eye on that, which I generally call the energy transition. So we will have to rethink our way of living and producing. So those markets maybe are more important. And then, unfortunately, we had the Ukraine invasion, which I will say, at least in my view, clarified that several commodities are only available in unstable political areas. And unfortunately, the role of these commodities is not trivial, but is becoming more and more important. So why I'm saying so? Because I believe we need new models which should be relatively flexible and possible realistic, and what I mean structural models, because those will give us the intuition where what we can do to be in a better world from now to 2050. So I'm not talking as most of the talks here next month. I will have part of the material where I'm forecasting hourly, so I will go back to a very short horizon. But what I thought when I was doing that, it was to have a much longer overview and try to give us a direction, how we should work and what to do. So eventually, the other element about this presentation, I just have intuitions of what to do. I don't have a result, because despite I'm investing from 10 years, I'm not yet there to have the final solution. You will understand, I think, why. So what I think, I believe that in these macro models, we should try to incorporate both better the energy markets, but also try to experiment what can happen with extreme events. That's typical, and try to think how we can implement the mitigation policies. And you will see what I mean here, because the transition is not cost-free. It will have a huge impact, and I will try to have a graph just to indicate what I mean with that. This is as an econometrician. As soon as we make these models more complex, of course, we need a new estimation technique. That's where I started in the last few years. And probably more importantly for today, what I also think we should learn more the basic properties of some of the markets. I think we know well oil, we know a bit less gas. Most of us did not know electricity. So myself, to learn more, I started to work, of course, in South Tyrol. Electricity is also hydro. So I knew a bit from Norway, but not enough. In South Tyrol, we depend on water coming from glaciers. So a couple of years ago, they took me 4,000 meters to go to sea. We had 2 years, experiment where we had a camera 2 times a day to see what was happening with the glacier and how the snow was evolving. So I learned a bit about the concepts, what happens when there is new snow, which not necessarily means new glacier. It's a different story about that, how it's melting, what is the importance, and probably the most important element, how much of the snow on the top goes down back in the basin there. Myself, I was above the Stelvio as a glacier and way to learn. And I find that fascinating. I hope I can motivate some of you and we can work more about that. So what I will do, I will briefly review some of the standard macro models that can handle, at the moment, this type of approach. What I mean is a DSG model, where there is an intermediate energy producing sector. This is where we are. This is, I don't think, is enough from my point of view. So I will discuss some ideas how to extend that. I will briefly review that. I'm sorry, I'm pushing a bit my literature. Maybe I'm also skipping. as you will see, we need more flexible estimation methods. So I will briefly review one method that I think can help in this direction, because it allows for larger nonlinearity, fat tails, and lack of data, which is what I think we are facing at the moment. Then I will go back to the electricity market, because none of these models are handling the electricity market. So I will try to show you some features about the electricity markets, mainly from an econometric point of view, so to understand what we need to do in the future to try to model this series, and where I think we should focus more. And I will finish with a simple, so I won't take the DSG, I will take a much simple structural model called a structural VAR model. It's very simple. Here there are people which I learned about that. I'm thinking about Luca, which has done a lot of contribution. I will just make a very simple approach with Italian data, just to explain you how things can vary and what we should expect about that. So the DSG with the energy sector, what is around at the moment? I just took one example, and I think most of the literature is focusing on this approach at the moment. There are two types of agents in this model: the producing agent, the entrepreneur, and the savers. So we are the savers, and there is someone taking advantage to produce about that. So it's very simple word. They are both maximizing their own utilities. There is a difference between them. The entrepreneurs are impatient, so they want to produce and make wealth, create a new wealth. We, as a saver, we are slower. We save for the future. That's the basic idea. What does it mean? We do have, the two agents have a different discount factor. Usually, the entrepreneur is smaller, the discount factor. What are the goods around the economy? There is a fixed capital, energy capital, and a non-durable commodity. The non-durable commodity is the key asset here, and we'll come back. Why? Remember what I said at the beginning, we focus on oil because it was easy to manage. Unfortunately, now we want to go away from fossil. We need new asset, and most of the rest, renewable energy sources, are non-storable. That's the problem. We have sun a lot, we have wind a lot, but we do not know when we have them. And matching the nature with our own needs is not trivial. And we don't have yet the batteries to store these type of things. So that's the challenge that basically we will have in this model. So it's good to have a non-durable commodity already inside here, because we can start to handle, at least from an easy way, this problem. There is another important element, which I think is true also in the current economy. Is easier and more productive to produce with the fossil if we do not account for pollution. The simple reason, the one I said, you can store and use when we need. But of course, that's where I believe the policies and the governmental policies should enter. How it is done in this model via carbon tax. So we are going to take from the polluting but more productive sector to transfer wealth to the less polluting but less productive at the moment sector. This tax should balance and push up the other sector. So it should make an equilibrium about that. You will see in this model there is not yet the other sector in the one I will present. And who is doing this job? The carbon tax, of course, but also we as savers, we can push. We can invest in one asset or in other type of asset. So let me do with this graph, try to explain how the economy is and why it's challenging the problem. So there are two assets here. One is capital on the X, and on the Y we have a marginal product of asset. If there are no restrictions, which means capital can flow freely, and we don't care about the pollution and so on, the equilibrium will basically be here. We put as maximum possible capital on the most efficient, meaning the one producing more asset or entrepreneur, and will maximize both the product and the use of the capital.
Sorry, capital is is free to move across sectors.
Across sectors in this case are easy, savers and entrepreneurs. So we can put the money where we want, entrepreneurs can have all the money they like. That will be the basic assumption. Of course, this is never happening. There are some restrictions. So let's enter in the other two equilibria that I put, where there are constraints. The constraints could just be in the capital at the moment. So suppose there is only on the capital the constraint, so we do not care about pollution, basically. So no carbon tax in this model. The equilibrium will be this H here, which keeps productivity high, and basically some of the capital is not able to go. And if you think this is the typical financial friction model, the one that was used to model the financial crisis. So there are inefficiency in the financial markets. We are not able, some periods where you like, to efficiently use the capital. There are missing information, asymmetric information, and so on. But now we have a new problem. We want to have the carbon tax. So we want that some of the capital is at the moment not used in the most efficient way, because there is a new goal which does not enter in the utility function, which is the pollution, for example. If we fully apply that, so we introduce a large carbon tax, this is what happens, which is a bit in one way, a simplistic way of what the Italian government is trying to do at the moment with issues about the taxing the rest producer. So at the moment, what is happening on the electricity market? Electricity prices are extremely high. If you produce electricity with gas, of course, gas price went up. This push up the production. If you want to produce, you need to pay more. The market functions with this idea. It's a marginal price. So the price will be done when demand and supply are matching. So the most important element is the last one to produce to meet the demand. This is setting the price. So it's really the last one entering. Why? Otherwise, we cannot set the demand. And think about ourselves. None of us can change the demand of electricity in the short. Forget to tell me that today I should do something more energy intensive at, I don't know, 1 p.m. and not at 12 a.m. But maybe the shortage is at 1, not at 12. And we cannot store electricity. To take it from 12 to 1 is impossible. So we need to use what? The fossil. What is the easiest fossil to use to produce electricity in a short time? Burning gas. And that's why in Italy we have 50% of electricity produced by gas, unfortunately. Of course, if we could have other methods, maybe we'll do differently.
Francesco,
yeah.
Why when you reduce capital, the marginal product falls? I mean, maybe used to
Exactly. So the reason is because in one way there is the entrepreneur is less effective in the assumption of this model or using this capital, because he has to is more capital intensive in one way to produce the same output than previously. There could be various reasons. I'm thinking about, again, the electricity. We need more investment before that the capital is out. Just think about the simple example, the windmills. You need a lot of investment at the beginning before that the windmill is up running. So in Italy at the moment, I checked last month, but I think we are same issues. There are 1,500 projects which are stopped in the ministry, and they are there from 1 or 2 years that will be useful for producing electricity. If you are one of the sponsors, that means that you put some millions or 10 millions of euro there in a project, which at the moment is stopped, and you don't know what will happen about that. In that sense, the capital, the fixed capital, in one way, I'm reducing the use of this fixed capital, which is also reducing, unfortunately, the productivity about that. Obviously, in the long term, this should be solved. This we should go back to what you said. So is, in my view, the reading of the literature myself, that is a temporary issue. But the temporary could be 5 to 10 years. So that's the challenge in one way. The tax, what does the tax? the tax helps us to push a bit higher this productivity by basically how? The simple way that I can think is the solar plants, we give more money to these people. This helps to produce a bit more, even if it's not costly efficient. That's the idea of the model. So you will see, even if I'm here with the tax, I'm retransferring from one sector to a group of sector to the other, and I can jump to a higher productivity, which hopefully we believe is the long-term productivity, so will solve part of the issue that you were discussing, indeed, that you see, that the productivity will be higher with even less fixed capital. So that's the tax is exactly solving the problem Lorenzo was mentioning. Whether it's efficient or not, let's see, and what the government is doing at the moment is debated. Yesterday came out with the Decreto Aiuti, and there are a lot of questions about that because some of the elements seems not to tax the marginal product, but it seems more to tax the investments and everything, the VAT, so it's not easy to implement. So we should say so. So my idea will be, what are the limitations about this model, this current model, where we want to work? First of all, there are two agents, savers and entrepreneur. But the entrepreneur, they are all the same type. We believe, or we hope, there are new entrepreneurs, maybe also financed by the financial sector, which do have a different goal. So maybe for a period, they are willing to be less efficient in terms of productivity because their own utility function will also have global warming, pollution which we cannot measure in these acts. So in my view, we should start to think a model which should have two types of producers, an energy carbon intensive sector, so the traditional one, which is at the moment the most efficient, so the one producing more, using better the capital, and a fully decarbonized sector, which we need to help. Because that will start to solve a part of the issue that now the tax is unclear. The tax here, sorry. I just told you there is an alpha, but how it is done is not clear at all. So yeah.
Just a technical curiosity. As your model say, multiplicity of solutions, or you have just a unique stable solution?
In this one, there is only unique. Okay, please. So the question is asking if the model, the one with the carbon tax, I assume, or the one, let's say, the constraint one, yeah, has a multiple solution or only one solution. Simplifying this way. It has multiple solutions, even this basic model, depending on the carbon tax. If there is not, or yes, the carbon tax. Because you do see in this graph that carbon tax is no model. It's just an imposition or not.
Do you make any special treatment when you go to the data in that case?
Very good question. No, that I see. Oh, sorry. And there is asking, sorry, I'm not able to remember about that. So the question, do you want to repeat it? Yeah.
Okay, so the second, it's just a technical curiosity, nothing. I was curious about when you take that model to the data, whether you impose some uniqueness condition for the solution, or you let things go. You just let things go.
It's very simple. It's drawn randomly.
Okay.
So this is something to improve. Absolutely. That's a good point. And indeed, one idea that I have in mind here, it should be a percentage of the production from them. But until you don't have, because at the moment you cannot impose that. Why? You have only one type of entrepreneur. So how do you characterize? Because you can think it's a percentage, so we calibrate to be a percentage of the total production. But obviously it would be nice to say we tax more one related to your profit and we transfer that. So that's hopefully something will be done better in that element in the future. And again, as I said, my thinking about that is because the fully decarbonized sector at the beginning will be less productive because they need a huge type of investment. It's not clear what will function. capital won't move very fast because we all say we should finance them, but then giving the capital to them is not easy. And the example about regulations and limitation is a very good example, in my view, about that. Moreover, what we miss in all these models, in nowcasting, I think we start to talk about extreme events. Because we had the COVID, now the war, before we had the financial crisis. So those were definitely extreme events. But from a climate point of view, any of the macro model is considering that. And in particular, if you think it's usually just something happening. Maybe we can shock that one commodity is not existing anymore. That maybe we are able, so the problem on the gas. But think about elements as hurricanes, which can really have a much larger impact. They can impact basically all our private life and business life. That's something we are not able yet to model, unfortunately. So why, as I said, I don't have any solution here. I leave basically open this, and I think I'm sorry about that in one way, but otherwise, I hope we apply for a PRIN. Hopefully, I will have something more in the future about that, and new people, motivated people working on this topic. What I've done, on contrary, was start to think, okay, I can easily understand that the model will be even more non-linear, probably multimodal, or with huge asymmetry, and for sure there will be fat tails. So what we have done, and start to do with some of my colleagues, was trying to, estimating this DSG model is sometimes difficult. They definitely require a lot of time. So the first thing I thought, we should try to push on more efficient way of estimating this type of things, and we should use methods that maybe we know, and we know they could function well on the characteristics we are interested to. And one of the methods that eventually I entered in contact when I started my PhD, but I always left there, and now I'm retaking, is what I define the mixture of students T by importance, sampling, weighted expectation maximization. Mixture can handle asymmetry, fat tail, all the things you like. That we know from basic statistics, the easiest way for us to handle anything that is not normal is adding a mixture. The T is more flexible than the normal. So the first part. Importance sampling, here I assume is very technical, so we'll just give an idea. We need a simulation to solve these problems. We do not weight equally the simulations. We try to weight differently depending on some loss function, some areas of interest. And we want to be dynamic. So we want to take full advantage about that. But if we allow only the simulation to adapt, it will take time. So I need to train how to learn more in some areas or less. How? Via an expectation maximization. So every simulation, I take the draws, I take the information I like, and I do maximize via the algorithm towards the data. So I'm training twice my, if you want, my simulation. First, via the importance sampling. Second, via the EM algorithm. You will see how fast it is. So to estimate the models with, 150 equations and 100 parameters, 2 economies. So I should not use the word, but it starts to be large in this framework. Takes 6-7 minutes in 12 cores. This is, by the way, since I use importance sampling and I use the EM, and then I can take a full advantage about that, it is easy to parallelize. So I make going one chain in one core, another one in another one, and so on. So if I have 100 cores, it probably will go down even faster. Here is how the algorithm function. We do initiate from something, apply the IS, then expectation maximization. Where I want to spend a bit more time, or 1 second, is on the mixture component. Why I think also useful. Not only because it can handle fat tail and asymmetry, but I think of what is happening for this model. Sooner or later, we will have this new sector, I assume. So assuming you believe on myself, we need this new sector come in. But I don't have data, or the new tax. I don't have data. How can I estimate if I don't have data? Because the problem we have at the moment, we don't know about this sector yet, and they are not there. So the way I think it will be basically adding another component. So I try to force the system by adding components, add another component in the mixture that could handle this element. And okay, standard things for assessing convergence. Just one graph about this method. Yeah.
Sorry, Francesco. I quite didn't understand which model are you estimating?
Here I'm not yet estimating this model. What we have done in this paper, we estimated the 2 countries model. So I don't have a 2 entrepreneurship, I have 2 countries, if you want.
So is it DSG, 2 countries,
Yeah.
DSG with the
One
entrepreneurs
sector,
and the savers?
Absolutely.
But just the traditional oil sector? Or?
Yes,
Okay.
yes. And it's applied to Canada, US. Where
So
Canada
you don't have
is,
the second sector, the one...
they are identical. The second sector, if you want, is another country.
Okay.
The 2 sectors are identical in the way of functioning, but they have different parameters. Because one is basically calibrated to Canada, and one is calibrated to US. Both of them, there is commodity. Canada is more important, obviously, than the other. Eventually, in this paper, we focus a lot also on the fiscal policy, not only on the commodity, because when we start to work, there was this idea, for example, our president, Draghi, said productive and unproductive fiscal policy. So here we could handle, so we spend a lot of attention to try to have the productive and unproductive fiscal policy, and from Canada, which is a small economy, how this can work with a big economy, which is the US, which I think is a bit our framework, because we are a small economy, Italy, close to Europe, which is the big one. So here the paper was more on that element. Hopefully in the future we'll do more also on the commodity about that. But just to give you an idea how the method works, so you see this is a simple exercise. There were 2 equations model. In red when the parameters are not identified, in blue when the parameters are identified. And if any one of you has worked with the DSG, we know one of the biggest issues is to identify the parameters. You can see if there is information, so the blue one, this is the beauty and the problem one way of the EM. You really go fast, you converge extremely fast. See how precise I'm already with this. So sometimes it might be even too fast, because maybe we are going to a limit of the maximum likelihood. That's why it becomes extremely important drawing more component of the T. Because if I'm missing something out of the likelihood in the current draw, I know I have a new component that is supposed to take advantage about that. In parallel, I should hopefully never converge to the same local maximum. I should be able to hopefully draw more. Those are challenges which of course are there, but at least we start to think. So I take a couple of minutes for this one, because I want to be 25, 30, so no more than 7, 8 minutes I want to take on that, which is related to the electricity market. And already mentioned about the issue that it's not possible to store electricity. And that's the challenge we have. So if we want to move more to a world where we rely on electricity, this we need to do. And I'm not sure we will have a battery in the short to handle that. I'm not sure in the next 10 years. So the good point about introducing the renewable energy sources, which is what the government wants to play at the moment, once you have done the installation, producing the marginal cost of producing with the rest, solar and wind is 0. Because you have that. The nature is giving the asset, so the wind or the solar. So producing with them is 0. What does it mean? In a marginal price, they will always bet at the lower level. The only rest, which is more complex, is the hydro. But we have an issue. We are lacking water. The hydro is a natural battery. So we can store the water. We can stop water and release when we need. The problem that is lacking, we use water for drinking, we use water for agriculture, and then in third, we use water for electricity. So that's the problem in storing and not to throw away that asset. In general, I will say that we are able to reduce the price. But as I was mentioning before, and as it's clear to everyone, fossil are still relevant. So the first criticism that I have to the literature on electricity, in particular the one coming from engineers, is that they do apply fantastic machine learning methods. They add 30 legs to their own model. They study all the sparsity they want. They forgot that we do care about the demand and supply. So the model should have all the demand and all the supply. We don't care only to predict the best price. So what I'm trying to do myself and other people, of course, was always to build the models which had forecast demand, but also production, which is uncertainty forecast, less production, and try to have a bet on the fossil prices. The nice element about electricity, remember in particular for the rest, they are really true exogenous to us. In the short, they are exogenous. The investment in the long maybe is a bit endogenous, so we push. But the sun, we cannot control when there is sun, and we cannot control when there is wind. So the price will completely depend on an exogenous variable. That's great, because we can model, it's one of the examples where really exogeneity in the short term, meaning tomorrow, is really not questionable from my point of view. Of course, what does it mean as an econometrician? We need to start to understand how to predict the wind and this type of variables, which I was not trained at all. So what we did in this paper is, okay, is enough to handle properly, let's say, the production. The demand is easy to predict. By the way, I open only one question about that. I'm working also with another firm to try to produce a national demand, so for Italy and for local customers. You know what's the biggest issue? The new generation meters are great because they give us in real time the information. Yeah, excluding there is the privacy law, and Terna is asking money for that. So with the new generation meter, usually we have a demand information with 2 or 3 months delay. So we think we are going to the new life. We need to model, usually on average 45 days, we need to model the demand with algorithm and then use them to forecast tomorrow. So how much we are throwing away our money due to a privacy law is incredible. Because there will be, each of us basically will have a real-time information, but it cannot be distributed, or there is a huge fee to pay. Anyway, so maybe this is the first thing that should be solved. Returning to us, what I've learned and I want to show you is that despite using models which are extremely, I will say, rich in terms of variables, it's not the end of econometrics. For example, these are the residuals of some of these models. Massimiliano before was talking about that. So these are VAR models with X means all the production side. Stochastic volatility, without stochastic volatility, and a T student. So I'm working really on the residual. Try to learn more about that. In red, you have the line when you use a constant parameter VAR in a rolling window. So I use 1 year of data and I estimate the volatility. In dark gray, the stochastic volatility model, so one option time varying volatility. In light dark, or contrary, we have when we also add the T student. And as you can see, first of all, using a constant volatility model is probably misinterpreting or biasing the estimation because it is an average. So yes, that's the volatility of the residual. So this model we will define, but it's a good question. We will define large in economics. Of course, for engineers, it's not. So we talk about a model which has 3,000-4,000 parameters to estimate, but I'm using hourly data. So I mean, it's only a question if the computer can make, not having information, because I have 24 hours a day, 7 days a week. So every day I have every year I have a 36.5 times 24, and I can take 4 or 5 years just to have the rest entering. So I have usually 10,000 data. Is not, I mean, it's the minimum to start this type of model. The key element is to handle the huge instability, the huge volatility on the rest. The wind, the solar has this path every day. The wind is completely crazy. As you can see anyway, the rest are basically introducing time varying volatility in our model because they have this partner. So we should model carefully. That's why I'm telling you, because when we will go back to the macro model, we need to handle that. The shocks won't be constant. The shocks will be of very different form across them. Second, this graph, only 1 second, is due to the fact that there is huge correlation among these are electricity prices, different hours. So we should account to the fact that despite this different producing at night and during the day, we can handle and take information from them. So I'm skipping a bit about that. So the last thing I want to say is to do an exercise where I try to show some of the ideas I put down in a structural vector autoregressive model. What does it mean? Here you have 2 variables, so we tell you there is a shock, which is ET. I think the variables are reacting immediately to the shock, and then there is a persistence. This model can be rewritten in this way. Why am I doing that? Because of course, if we do not impose a restriction, we are not able to estimate this parameter. So the counterpart of the SVAR is the VAR that indeed we do not impose restriction. But we are interested about that. We want to know what happens at impact. So how do we make this solution? Okay, let's take the 2 models, look where they are equal, and basically this part and this part should be equal. So it's enough we decompose this omega in some way that we can handle B. One example is the Cholesky decomposition. So we make this type of decomposition, an identical matrix multiply for 2 Cholesky matrix. What does it mean? This is a recursive order. You can see that the second variable is reacting at impact to the shocks, but the first one is already reacting at impact to the first shock. So ordering is important. Okay, that's a simple assumption. Let me try to do with the data. There is also Emanuele, which has worked a lot about that. Take Italian data from 96 to 22. Yes, Q1. So I show the graphs. 2 examples. One, I have Brent oil price on the top. Why? We do not control, Italy does not control oil price. I think I'm pretty much convinced about that. Even Norway was not able, despite they produce, they're the second or third larger in the world. Maybe Saudi Arabia is the only one, which can have an impact, but the rest are not. GDP and CPI inflation, and I call the shock commodity, so global commodity, and then Italian supply, Italian demand. Second exercise, I simplify things. I remove this one in one way, but I change the definition of inflation, and I take an energy inflation. Why? This is what maybe is happening now. It's a simplified version of everything. Energy price explode. What is happening to the GDP? Here the graph. So first one, the commodity shock international. Typical, this is symmetric model. This is a positive commodity shock, which means a demand. We are doing better. Commodity price goes up. In any case, Italy is a big exporter, so we will produce more, so we will export more, and we have a higher inflation. Supply shock, more or less okay, very short lived of lower inflation. So you see GDP goes up. Of course, we don't care, we are not important for the world, so important. Inflation goes up, but it goes down, but it corrects pretty fast. And demand shock, so this is a national demand shock. You see huge importance of inflation, much less on GDP, which in one way is due to, if you think, all the reforms we try to give money to people which had not an impact on GDP. Okay, that's just to try to understand the economy. Let's go to the new exercise. Only 2 variables just to make our life simple. You see the scale is different. Here we are talking about energy inflation. So here we are really what we have seen now. Symmetric, so you can take a minus of what you see here and have the same effect. So let's take already the minus. Increase on inflation, energy inflation, so cost us more. It has, you see, an increase of 25-30% will have an impact in this model. We reduce GDP of 2%. So there is an effect here on that. That is what we are experiencing exactly about that. The demand shock, so let's say that is not driven by the fact that supply is, is important on this one. Here is inflation, so for some reasons we demand more, which was before the war, basically. We go out of the COVID, we demand more, inflation goes up. That's the idea. You will see that there was an effect of GDP, but less important than expected. So I think it's very important, what I want to take from here is the model are responding in the way I was thinking, but we need to be better in handling the properties. So the most important information I had from that was a huge scale. We need for sure stochastic volatility. Probably we need T-student. In general, it's a fascinating approach. There is a lot to do. I'm trying to do something. I hope other people will try to do more. Thank you.
Francesco, thank you so much. Let's open for 1 or 2 questions. If is there any question from the audience? Please, maybe introduce yourself.
Yeah, Emanuele Bacchiocchi, University of Bologna. Thank you very much, Francesco. Very challenging presentation, stimulating, let me say. I have, to be honest, plenty of questions, just a couple of them. The first one, as an econometrician or an economist, I'm not interested in, I cannot produce forecasting for wind or, so maybe we should work much more closer with other people working on that. So this is, let's say, something that we should do. Another point is about when there are big shocks like COVID, like the global financial crisis, as mentioned by Massimiliano before, probably what I expect in some sense is that there should be also parameter shifts. Not simply higher or lower volatility, but also structural changes. I don't know whether you are thinking about this in your models. Thank you.
Emanuele, thanks a lot. Great questions. So the first one, I can only agree. I'm head of Department of Data Science, and in the spin-off, there are 4 engineers and myself. So I can only agree that I'm the only one not understanding 90% of things that people are saying. Anyway, the second one, this is a great question. I think that personally, my understanding is, in one way, in the short term, it's easier to handle the shock. On contrary, in this model, in particular, on the structural one, it will be great to start to think how we can handle that. My view, however, is not via the parameter at the moment, but will be via new sector. So we'll be happy to restructure the model. Of course, I can handle maybe also with the parameter, but I don't think it's enough. The shock I can handle via the stochastic volatility in one way, because I'm sure it will be transitory. The COVID was a good example. Then it went away. Now there is the war, hopefully it went away. But the structural, in this model, I will be more intrigued, at least in the DSG, by adding a new sector that can handle that.
So adding a new sector probably should also change.
Yes.
Sorry. Adding a new sector, I expect to change also
the
dynamics and so on. So
in this,
even more so in this respect.
Yeah,
I think.
Yeah, that would be my approach. Thank you that I went longer.
Thank you, Francesco, so much. Now is the time of Monica Billio from the University of Venice with a talk with title Climate Shocks. So Monica, the floor is yours. Just try to talk in the mic.
Yes, probably it's easier for me than Francesco since I'm small. Okay, thank you.
You just go this way. Okay, you can use this, Monica, here.
Okay, thank you. I can work with this. Okay, very well. Thank you. Then, first of all, thank you for having me here. I'm really happy for this invitation. Happy to, to follow the first two talks, in particular that of Francesco, since we are also thinking about the problems with the oil in this case, but when we try to discuss it, to introduce climate shocks and then the idea to deal with the climate change, clearly there are some sectors that are more impacted than others. Then what I'm presenting is a part of a joint work with Roberto Casarin and Michele Costa, that they are now in Venice, and Ca' Foscari, and Matteo Jacopini, that at the moment is at the Vrije University of Amsterdam with Marie Curie Fellowship. I start with the idea that when we need to work with a more complicated situation, when we need to work with a lot of data, when we need to work with, let's say, the possibility to deal with different aspects and put them together, we need to work with networks and the idea of connectedness. Then the type of model and way in which we deal with, it's okay, no, okay, with the different aspects, push us to work with networks. For me, for Venice, it is really a long, a long way, since at the moment, it is a research agenda of 10 years and more. But the effort that we are doing this last period, and this is the reason for which I'm happy also to present here, is to not only to work with networks, but to introduce the time dimension in network, and then to have dynamic network, and this opened the via to the possibility to first analyze the impact of shocks and then to forecast. And then this is really the challenge question with when you work with networks. Here, just to have an idea, this is the first type of application that we have done in really 10 years ago. It is when there was the crisis in the financial markets, and then here you have two examples, a lot of stocks in this case considered, and you have the connection, then you have the different vertex of nodes, then the different stocks in this case, and the edges connecting the different stocks. And here what you can simply see, and this is the time, the question of the connectedness, is that the situation is changing in period where there is a really high crisis. Then this is the situation of a highly stressed market, and situation in which the period, are less stressed than what we call non-crisis period. Now, as I said, the question is how it's possible to work with multidimensional data. Why we have in mind this? Since there are a lot of situations, but when we start to work with the idea to treat also the aspect related to climate and related to the potential different impact, not only on different sectors, but also geographically, let's say, then, the different dimensions that can be involved and then included in the data clearly start to be important. And it is not simply that, but also the potential ability to preserve and then to use the structure of this data, then maintaining the structure, then working directly with the network in this case, or a multi-layer network, but in this presentation it will be only one network, otherwise this asked for more complex way to describe the multi-layer network, okay? But you see that it is important to be able to treat directly this data as they are. and as you can see them, and then also understand the structure. Then what I'm saying is we need methods for multidimensional data. As I said, spatio-temporal, since we need to be able to treat the impact and then the different way in which also, in this case, since I focused a little bit more on climate, also geographically, but not only that, temporally. And then the point is how it is possible to model in dynamics for this type of complex time series. And once you have this potential, and then let's say you try to be able to maintain this structure, clearly the possibility also to understand what happened locally and what happened globally, then to have a view on both dimensions. And this clearly is also the same in time series than for the time dimension, since you can see at what happened temporary, then in the short, let's say, and what happened in the effects when you try to look at the long term, then more persistent effects, okay? Then the main idea that on which we are working, and I would like to give you one of the possibilities, and one of the things that we are trying to do is exactly the potential to forecast a network time series, and then to introduce first the time dimension in network analysis, and then try to forecast. As I said, I mean, for me and for several colleagues in Ca' Foscari, I mean, the networks is a research agenda that it is more than 10 years. And we really started at the beginning trying to see how it was the better way to extract the networks than to obtain the networks, since in a lot of situations, you can understand that there is an underlying structure that connect the different vertex or nodes. Then it depends, it could be firms, it could be financial institution, or it could be also different type of unit, but you cannot see immediately this network structure. Then you need first to extract. Also in the application that we'll see later, first we need to extract the network and then work on the network. In other situations, you can directly observe the network. Then, I mean, the work has been done trying to also introduce some structure, and then to move from the simple, let's say, observation that there are some linkages between the different units, and try to formalize this in a more it's modeling in some way. Then the paper that you see there with the colleagues and some of our PhD students go exactly in this direction. After we started really to work with the dynamic network. As you see, the dates of this paper are more recent than the previous one, since this is really the last steps of our work. And also with Francesco, we do some exercise and some work, and using in some cases the Markov switching or the time varying. I mean, this is also the easiest way, in some way, to introduce dynamic, to understand the dynamic. And as I said, we work also with multi-layer. Then in this case, we are obliged to use tensor, but as the paper with Silvia Kaufmann, Roberto, and Matteo Jacopini. And but I mean, for today, I prefer to remain on the matrix dimension, since it is in some way easier to understand. Another thing that can be done in the middle is the fact that a different way in which we can understand the structure that is in this network, and then also use this information using the topology of the network, then using how the network is done, and then extract information from this structure and use this as a complexity measure, early warning measure, and so on. Then there is also this analysis that can be done in between, and that can move from the extraction of the network, then understanding of the network, and then the way in which some of these measures can also help after in the modeling the dynamic and trying to forecast the dynamics. Then, what we do, I mean, to have this new multidimensional model for network time series, in this case, maintaining this idea to account for the natural structure of the data, to maintain also the potential to see the data as they are, and then work with, this is usually the case when you use network data, then deal with big data, then a lot of data, then also be able to treat this point. Here we work with multiple regimes via smooth transitions, then in some way take into account the observation than before what happened, since in the data there can be changes. And then trying to introduce, I mean, specifically this idea of the way in which we can introduce climate shocks, then climate events, in this case, shock on the network. From the point of view of specifically of the forecasting, as I said, it is really a challenge for the network, since clearly already the network is really a complex model. There is a high dimension. When you start to work with the idea to have the temporal dimension, this means that you have at each point a lot of data, and then once you start to have different periods, clearly this means difficulties, let's say, in such a way. Here, the work is done first by extracting the network, and then working directly on this extracted network, and then using the information there to obtain the dynamics. A dynamics that is introduced through a smooth transition in order to also to make us able to do some impact analysis and scenario analysis, and then move in the direction to be able to forecast. As I said before, we'll also work differently, looking at potentially at local level, at the global level, okay, in such a way to completely use the structure of the network. From the point of view of the analysis in terms of estimation, let's say, and here, and this is not only for our works, but really in general, the type of methodologies that are proposed, and both for the extraction after working, are mainly in the Bayesian framework. And we contributed to this part of the work. And as you see, a lot of work has been done also by other colleagues, usually introducing var on one way, then vector autoregressive models on the other way, trying to introduce in time varying, then having the possibility to see what happened through this type of methods: smooth transition, Markov switching, time varying parameters. After the point is to be able to study the evolution of a network, as I said, and at the same time to use, as far as it's possible, realistic model in order to account the relevant features in the data. This is the reason for which, in order to account for the stylized facts that are clearly and well known in finance, but also when we move to the energy markets, I mean, there is quite important non-linearities in the data. Then on one side, we need time-varying parameters, and this specifically it is the smooth transition. In other paper, we worked with regime switching, and we also need to deal with some fat tails, and then the choice also for the error term, or in our case, a t-variate matrix. As I said, we do not, I mean, a lot of work is done also in the literature, vectorizing the data and then obtaining vectorized matrix data. Here we try to avoid this choice, and then we work directly with the matrix data. On one side, because to vectorize means to increase the dimensional problem, and then it is after even difficult to work with. And on the other side, this means to change the structure of the data, and then it becomes after difficult to understand. The application that we will see for the model here is the production of oil in terms of connection from the different countries. The data set is not a recent data set. It was chosen also in order to understand eventually what can happen after. Clearly, the current situation, and then several events in the following year change the picture clearly, but it remained the interest in analyzing what is the impact anyhow of the climate variable for this type of data. The other application, but it is in the slide for people interested, but I'm not presenting today, is for the financial markets. That, also for this type of market, more and more the climate change driver becomes important anyhow. Then this is what partially Francesco said before. At the moment, there is the carbon tax, but a lot of things are doing now in order to push the financial market to try to having the investment in the direction of the transition, and then having also a lot of financial incentives in this direction. Okay, now. As I said, we work then with a matrix variate. It is a smooth transition model. It is an autoregressive model, but a matrix autoregressive model. We account for potentially regime and structural changes in the data through the smooth transition. And we take into account the potential of outliers and fat tails and so on using a matrix T error distribution. And as I said, we look more at the international oil production network, also including climate variables, climate-related variables, in order to understand what happened in ordinary period and extreme period, this for the oil production, and then allowing the possibility for scenario analysis and the climate policy implication. Some technicalities I try to do in the easiest way. Let's consider this calligraphic G here a temporal network. When what you have is this GT is a weighted network. Weighted network means that you have the set of vertex then the nodes, let's say, you have the edges, then the linkages, and these linkages are weighted. They're not simply 0, 1, they are weighted. Then you have this weighted adjacency matrix that represent the connectivity structure of the network. The model that we propose is defined then on this real valued matrix YT, and this YT is a transformation of the weighted adjacency matrix. It depends on the way in which you want to work. It can be exactly the adjacency matrices, then the relationship between Y and Z is the identity, or if we need, it depends on the type of also of formalization of the smooth transition that we want to have. It can be a logarithmic transformation to have positive valued edge weights, or a logistic for edge weights in the unity interval. Then they are simply transformation in order to obtain the YT in the form that is more interesting for the model that we are considering. We are working with a smooth transition. Then in our case, the identity will be fine, but we need to introduce this capital phi function that is, it is with J, as you see, it is a sequence of smooth transition matrix function that explain the transition through a variables x and the parameter d, and clearly need to satisfy the sum to 1 constraint. This is written in the matrix form, but it's simply that. Okay. Then the model is YT, the transformation of the adjacency matrix, as I said before, and then of the connectivity among the different nodes as a simply we think to have J regimes, and then it is the product between this transition matrix function and the beta that are the regime-specific matrices then of the impact, the parameters, okay, and ET at the end is a matrix variate noise that I will say a few words later. Just to be clear, the matrix of the transition function can be quite flexible. I mean, clearly to have a specific transition function for each element of the matrix, a little bit too more, but we can think to have the possibility of row specific, then by row to have this type of smooth transition fixed by row, fixed by column, or the simplest one is to say that it is the same transition function for all the elements of the matrix of Y in this case. Here for the example also to really to allow us to understand what happened, we have a common transition, then the simplest case, a 2 regime models. It was enough since we have in both situations standard period, let's say, and stressed period or impact of extreme events or specific situation. Then here it is presented with 1 covariate. In the empirical application, it is with more than 1 covariate. And what we see better in the application is the absolute logistic transition, what you see there, where alpha is the slope parameters and delta the threshold parameter. Essentially, we use 2 parameters, but it is not a simple logistic transition, but an absolute logistic transition. Here you see the differences among the potential choices, then the logistic, the exponential, the absolute logistic, and the quadratic logistic. Here, also thinking about the potential of abrupt change, we prefer the absolute logistic. Then we have this point that is really the change. For the error term, we have a matrix variate T. Do not worry too much about the formula. It's just the formula of the matrix T. as usual, you have this the degrees of freedom, okay? Here, the degrees of freedom are 1, then it is the same for both dimensions. It is a matrix, then there is 2 dimensions. And, but there is 2 different positive definite matrices, sigma 1 and sigma 2, for the 2 dimensions. Then there is a change in differences in the structure of the variance covariances in the 2 dimensions, but the number of degrees of freedom are the same for the overall matrix variat T. Okay? Then to conclude in some way, the model is the one presented. YT, as I said, it is potentially it is a transformation of the adjacency matrix. Then YT is a function of ZT, as we said, where the conditional mean MT is this, for the specific case of 2 regimes and a common transition function, it is B1 and B2, and then you have phi that depends on the xt and the 2 parameters, and 1 minus phi for the second regime. Okay, the transition, the absolute logistic transition. And I mean, the way in which it has been defined shows us that the conditional mean and the conditional variance are as you see here. Then MT is the conditional mean. This is quite easy. And if the number of degrees is bigger than 1 and at least 2, you can write the variance in this way.
To understand. So is this, I'm not sure, is it different from the multivariate regression?
It's different from?
Multivariate regression.
You have directly the matrix. You work with the matrix. Yeah. Okay, then it is not the vectorized matrix.
Okay, so it is a multivariate regression. Okay.
Yes, from this point of view, it is a multivariate regression. Okay. Yes, it is directly of the matrix. And then also the error term is a matrix. Okay. The choice is for the T, with the number of degrees of freedom that is the same, but the 2 dimension has 2 different variance covariances in matrices that you see there, sigma 2 and sigma 1. Okay. Here.
Sorry, this may be a naive question, but how do you switch for the error term? So you have the phi function on the M?
Yeah, but the error term is a T without smooth transition.
So, but you have 2 variance covariance matrices.
Yeah, sure, because it is a matrix. You have 2 dimensions.
Okay. Okay.
This is the point. You have the 2 dimension, and then you have to combine. You have information, and then potentially differences in the variance covariance in the 2 dimension. Then you are right. Good observation. The sigma 1 and sigma 2 are not related to the fact that we have 2 regimes. Potentially, if we have J regimes, they remain 2 variance covariance matrices. They are related to the matrix dimension. Okay, then we have the fact that you have 2 dimensions in the matrix. And then they go in this way. Sorry, I lost the possibility to.
Maybe you are done. Just kidding. No, it's actually.
May I move? We need help.
There's no moving. I don't want to mess it up. So.
Non riesco a spostare.
This.
Ok, lo faccio. Ok.
It was easy. Good.
Then here we are. Then 2 technical slides just to say that we are in a Bayesian setting. Then we need to specify, but I think I lost. No, it's okay. We need to specify the priors. Since we have the priors, and we have the simulation step, let's say, and then from the posterior we obtain the result. Then here it is the priors. The priors are setting according to clearly some choices and some also need to impose constraint, in particular for the covariance matrices. They are independent priors, but clearly we have some problem related to the fact that there is a connected product there, and then we need to identify the two matrices, and then we need this identification constraint. A prior for degrees of freedom that is not fixed, but it is estimated, and then for the slope and threshold parameters that appear in the smooth transition. Just to simplify our life in terms of Bayesian specification, we have a data augmentation step. Since the matrix T distribution can be rewritten as a scale mixture of a matrix normal distribution, then we add these auxiliary variables, that is the representing the different element of the mixture to describe the matrix T distribution. Okay, they simplify our life in terms of the Bayesian analysis. Then, given this data augmentation step, then the adding of these auxiliary variables, we can write the complete data likelihood, and then we can go with the posterior approximation through simulation. In this case, it is a complete Gibbs sampler. If more or less, I mean, the idea that in the Bayesian we work with the prior, we need to simulate to obtain, in this case, the posterior, since we are not able to obtain by analytically the posterior. The posterior is obtained through the Gibbs sampler. It is a complete Gibbs sampler. Then there are the different pieces that give us at the end the result. Here it's just to specify the different distribution that have been used for the Gibbs steps. As I said, I have how many?
I would say 10.
Okay. Okay.
No, less.
Okay. I go with the, as I said, with the oil application. We then consider the network among the oil-producing countries in this case, and the network extraction has been done here with the first way in which we work it. Then it is simply a Granger causality approach. Since the dimension is anyhow important, then we obtain this directed network and the related weighted agency matrix. Each element of this weighted agency matrix represents the p-value of the Granger causality between the two countries. In this case, if the country I, Granger causes the country J at time t, okay, and for this analysis we work transforming this adjacency matrix, the weighted adjacency matrix, through the logistic distribution to obtain our Y with which we work. Then this is the edges of the oil production. Then here the analysis have been done on the 17 oil biggest producers. As I said, the sample period is 98 to 2015. Then there is nothing about, let's say, this last period. From this point of view, it is less interesting. But I mean, what we do first is to analyze this data, considering, as I said, the lagged degree. Degree is the total number of connection in the network. Then what we do is to use one element describing the topology of the network as element helping us in explaining the transition in this case. The lagged clustering coefficient, again, it is another measure that we can extract from the topology. And in this case is how there appear cluster in the network, and you also consider a real economic activity, in this case, to take care of clearly of the general and the global economic dynamics to explain what can happen. And as I said, we had this extreme weather condition in order to take care of the climate shocks. Here it is the network in two different periods. You read the networks, you have the nodes are the countries, and the description is not really in line. Then look at the picture, but not at for some figure I saw before in train, but it was too late to change. The description is not always perfectly in line, but anyhow, here you have two oil production network. You see clearly the connectivity change during time. The total degree represents exactly the number of connection appearing, that you see it decreasing and then increasing. And you read the graph looking at it is a clockwise connection. Then when you go from the left to right to see the direction, and this node.
Sorry to interrupt you. What do you mean by oil network? So
here it is the connection.
Is the production?
Here they are
because this looks like a game also, not only a.
No, in this case, no.
There's a cartel and so on and so forth.
No, in this case, no, since, as I said, we extracted the network looking at the causality among the different producer in production. Then in some way, looking at the causality structure among the different oil production. This is a point, the way in which we extract the network clearly can be done in different way, okay? And then eventually, as you are suggesting, looking more at the way in which the price of the oil is fixed and not simply to the production. I think you have in mind.
I'm not sure what I have in mind, but the thing is that, there is strategic interaction between the oil producers, and I was wondering how this connects to this idea of the network.
Here it is the causal relationship. Then here this type of consideration is inside. And the fact that do not observe only one structure, but to observe the causality structure moving time, allow you also to study this type of consideration. I repeat, it can be done in production, as we have said, okay, but it can also be done in terms of setting the price, then looking at the way in which not only the production, but also the price is settled, or looking at both things. In that case, it would be a double layer, but clearly, if the interest is more in understanding the strategical way in which the different countries move, this would be really interesting. Possible, not done here. Okay, here is to see the impact. Remember, we said that we consider the degrees, the lagged degree, the lagged clustering coefficients, and then this real economic activity and extreme weather condition. Here it is the impact, then the way in which the transition, okay, appear, just to understand what happened, but to see better and then to understand and to describe. Here, I repeat, it is the topology dynamics in terms of degrees. What we see is that, some particular situation like in March 2004, the choice to change, to implement or cut the oil production that appear as a change in the structure. This is the first graph, okay. While there is a peak also, thinking we will see better when you think to the hurricanes. In this case was Katrina and Rita. Katrina, you probably remember. Rita, a little less. But they impact quite importantly. No changes, no real changes in terms of the clustering coefficient. Then this means that the specific structure of the network in terms of potential cluster does not impact, and also the economic activity. As I said, we also add this specific variable, take into account extreme weather events, and then see how this impact on oil demand clearly through the electricity consumption channel, but also how they impact on the oil supply chain according to the, for some extreme events like hurricane and so on, they impact also not only on the oil supply chain, but the energy distribution, thinking more to the US, and then clearly this impact on the production and distribution. I'm at the end. This variable that we consider is the consecutive summer days, then the sun on one side, and the other side the precipitation, then the number of very heavy precipitation days, such a way to take the really extreme events, and the standardized precipitation index. Okay. Here, the analysis have been focused more on the European countries, and in particular, we have also distinguished between the north and south, just because on one side there is these differences in terms of summer days, but also on precipitation days. To look at the result very quickly, here it is the specifically the number of sunny days related to the sun. You see clearly the seasonality that appear in the activation of the regimes. This is for the first is the north, south, and the global. Here, the differences is the impact on the north, the south, and then globally. For the sun, there is not really, but if we look more at the differences among the estimated coefficient that previously was not so clear, you see that the first matrix show you the different coefficient for the global impact of the sunny days, while the second is for the north and the last is for the south. It is clearly the impact, but this is also expected impact for the south more than for the north. If we look at the precipitation, this is the graph. Also here there is quite important differences from the north and the south. This stagionality is less evident for the south. Here the situation is more in line, and the last is just for the this standard precipitation index. It is a more standard index, and also in this case what you see is that if you look at the global, that is the first, you completely lost everything, since it appeared that the two metrics for the north and south combine in such a way that the global you see nothing. Okay, then clearly also this the potential to look locally and not only globally to the impact give you important information. I conclude with this, and I'm done. Thank you.
Thank you, Monica. Let me see whether there is just one, if there is any quick question. Okay, I think everybody, we went through a lot. So we'll take a 10-minute break, and we resume 11:30 for the final panel, which will last about an hour. So you can get some drinks, and we'll resume in 10 minutes. Thanks.
Grazie, Lorenzo.
Of the conference, and we welcome our three special panelists. We have Andrea Carriero from University of Bologna and Queen Mary University London, Luca Fanelli, a former member of Prometeia association, and now full professor of econometrics in Bologna. Yeah, when you were young, and same for Roberto Golinelli. Okay, so we have heard a lot of interesting topics and issues during these 2 days, but there are so many issues that we haven't touched or we could explore a little bit more. So I will make a few questions to our panelists, and then later you are also very welcome to add questions and raise discussion. The first one is about the history of macroeconomic forecasting, which has been very long, and during time we have witnessed a lot of changes. Sometimes models were based mostly on data, sometimes on the theory, sometimes of both. So my first question is, I would like to know your thought about these changes in an historical perspective, and also it would be nice to see to know what you think will be the next workhorse for the industry of forecasting. I think, Roberto, you could start with an answer, not because of the age, but because among us, you are the one with the longest experience in macroeconometrics.
Yes, in fact, I started to work in Prometheus when Prometheus wasn't here in 1983, and Pardon?
You have to talk close to the microphone.
Close to the microphone, okay. And my first long-run forecast had the horizon of 1995. So 27 years ago was the difficult ending of my first long-run 10 years forecast. So in all these times, many things tends to reproduce over time. And of course, when you ask me about a forecast and macroeconomic forecast, for me is something to be declined in the terms of macroeconomic models forecast. And the macroeconomic models for forecasting and policy analysis are characterized by criticism. Since when, and even before, of course, when I started to work with these things, there were always already a barrage of criticism regarding the irrelevance of these models, because they don't tell enough about issues that are of interest of the markets and of the policymakers. And these models are inconsistent because they are not so consistent, of course, with the economic theory. And these models are also inadequate to account for data. So these are criticism at the time of Pesaran and Shin in Pesaran and Smith in a paper on economic modeling of 1985. So regarding these points, this criticism, the macroeconomic models always tried to defend against this criticism, and in particular, we note that many reactions of the macro model were just to answer to this criticism. But I think that the most important point that is not, in my mind, enough well and enough strongly stated regards the claim of Box and Jenkins, that says all models are wrong, but some of them can be useful. So in order to assess the relevance and the way the model implement the techniques to give answers, we must decide what is the usefulness of model in doing something sometimes specific. And so the modeling approach is a sort of a goal-oriented activity. And of course, given different aims, can give different models, because it's impossible to fully satisfy the criticism about the inconsistency with the theory, and the criticism about the inadequacy with data. So models are inadequate to represent data, and in this, with regard to this problem, we can try to make a sort of an axis, two axes over a Cartesian plan. So taking the idea of Adrian Pagan, we can think about the modeling activity as something that can be represented by a diagram that shows macroeconomics model are lying along two axes. Along the vertical axis, we can imagine to measure the extent of the degree the model is coherent with the theory. And along the horizontal axis, we can measure the degree about the coherence with data. Of course, given that we have a trade-off, we can imagine that a different composition of the two ingredients can be drawn on an isoquantum where we have the best practice. So along the best practice line, we can assess the relevance of the model with respect to these two conflicting issues. And in this way, we can understand the fact that the SGE may be less informed by data, less measured in considering the data, while VR models or the statistical approach, many of them illustrated this morning, can be, of course, purely statistics. So they got a lot of information from data, and of course, they are not much interested in the theory. Well, so this best practice, a long time, tended to expand, tend to go outwards because of the computer power, because of the better theories that are able to explain better what happened, and of course, because also data and data availability is better today than yesterday. So thanks to this, we had this frontier of the effectiveness of the model to answer the questions for which they are made tend to expand. And the point is not be inside the frontier. And to stay on the frontier, we face a trade-off. This is quite simple. And so probably an academic economist can be more interested in making works, applied works, that take the point of view of the DSG model, because the data point is in some sense less relevant, and we can simply speak about stylized facts, and so we can try to weaken the link with data. On the other side, the business and the commercial world is still interested in models and forecasts that are deeply rooted in data. And for this reason, probably Promethea, National Institute, Cambridge Econometrics, and so on and so forth, they still produce a model of a more classical, let's say, historical view category, that in the context of this picture, they can be termed as hybrid model. Today, the hybrid model is a model where, with this model, we try to provide theoretical funded predictions, but these predictions are based on models that are estimated relationships. So in a very simplified way, they can be things like a sort of vector error correction mechanism. And we have cases of this model in the Central Bank of Sweden. We have a couple of them in Australia. And so this model of course, are, in my view, still best practice model if you have the idea to make a forecast for a market that is still interested not simply in a number of idea or stylus facts, but in relevant forecasts that are relevant about the issues that are at hand. So, however, the relevance sometimes makes things more difficult because model needs to enlarge. And so if you want to enlarge, like in the SG model and in any type of model, we won't be more effective in answering questions about the environmental and energy issues, like shown this morning by Francesco. Of course, we need a bigger size, a bigger structure, and this is what always happens when the model wants to be more relevant. Very often becomes bigger and bigger, and from time to time, the modeler tries to reduce the dimension by cutting some pieces of the big model because simply the question is not more relevant. But also this is a forecast. When in 2018, the Federal Reserve decided to cut and to simplify the production part of the model by simply get rid of any information about energy. And so this simplification probably today was not a big idea. Probably now they will have to resume the version of the model that works today. So at the end of the story, the policy modeling implication of all this is start from an explicit goal and try to appropriately mix theory and data to make a best practice model. And in this, it depends. At the end of the story, what is the perfect combination of these two ingredients depends on the market, depends on your institutional links and so on and so forth. But the point is, be careful in choosing what is your ending point, where you want to enter in the debate.
Thank you, Rob. Did you check ex post how your 10 years forecast were?
That is a good question, but
yeah,
given that those...
The nice thing of doing long-run forecasts is that nobody checks ex post. So.
Yes, this is the point, because if you check a forecast, you check the forecast over the first 2 years.
That's it.
And so we never. But this is I can go to. The point is what vintage of national account to use to make the forecast error, because since then a lot of not only basis but other things, black, gray economy, and so a lot of points have emerged. So I can choose to minimize the forecast error by choosing the most favorable ex post results coming from data.
Thank you. Thank you, Rob.
Yeah, maybe because your question was like, where are we going with them? And to follow up from your final point on mixing theory and data. And I see that. I believe that there is definitely a trend in which perhaps we are finally getting there to finding a way to mix theory and the data in a good way. And in modern macroeconomics, there is an increasingly use of Bayesian approaches, and that is a really very well grounded way to do this mixing thing, because basically the idea is that you can use your theory as your prior information. Now, we have seen a couple of papers which were talking about Bayesian approach, and of course they didn't go through the details, but of course the specification of the prior, it's a very important step in that framework. And it's a very good occasion to actually put, economic theory to work. So, I mean, and there's been a lot of contributions, and this is increasing over time. So I think that that's the direction in which things are going, and it's a good mix.
Okay, now this is an interesting point. And I mean, on my left side, there is someone who refuses to do Bayesian inference. And there are still some people left working with the concept called likelihood function and likelihood inference. And so, Luca, what's your view about this? I mean, of course, we know already what the view is, but maybe you can add something.
And do we need it?
Okay. Okay, first of all, thank you very much. It's a great pleasure to be invited here. I have to say, I have to premise that the real expert in forecast are my colleagues and friends on the left and on the right. I am an econometrician, but I would not say that I am an expert in forecast. But I have to say that I started if I am an econometrician, this is due probably because of the wonderful period of my life I spent in this institute, not here. It was in San Vitale something in '94. I was just graduated in econometrics, and I had the honor and of working in the estimation of the financial sector of the Italian economy. And concerning about checking the forecast of models after I was mentored by Stefania and also Professor Paolo Nofri was a mentor. My greetings to him. And okay. My greeting to him. It's I remember that as a wonderful period of my life. Very, very, very nice period. And after 10 years, Stefania told me, well, you know what? We are still using the model we estimated, and say after 10 years, I can't believe that. So that was a great one of the that was great, really great, and it works. He said it works. So it was one of the great satisfaction of my professional career, I have to say. But anyway, coming back to more serious stuff. Andrea was mentioning Bayesian, the Bayesian approach is the future of forecasting. Yeah, probably it is so because Bayesian analysis allows to estimate, very complex model. And we get an example by Francesco with this, I have to say, wonderful DSG model, including, price of energy. The only way, if you want to go to the data with that kind of models, of course, the Bayesian way is the only way. So my point is that sometimes we go Bayesian, Andrea, it is just out of convenience because we can do otherwise. But also, as an econometrician, I have to say that Bayesian way sometimes also is a wonderful way to go, but sometimes can also hide some of problem issues in identification of parameters, blah, blah, blah. And I agree with you that from a computational point of view, that is the way. But from my point of view, I think the way should be kind of the problem we have in forecasting that people who really do forecast. The problem is facing instabilities. That is forecasting in an unstable environment, and how to do that. That is from my point of view, the crucial question. And as far as I see the problem. One thing I say to my student all the time is that there are three things. I mean, one is that if you want to make forecasts on a subject, you can have a wonderful model. You can be an expert of wonderful techniques in order to evaluate whether your forecast is good. But if you're not an economist, if you don't know the economy, if you don't have the flavor of the number you're forecasting, forget about these wonderful things. And I have to say, I had the privilege, a couple of times when I was in Promethea, I was a young guy, very shy young guy, And I was allowed to participate to the scientific committee before making forecast. And a couple of times, Professor Benemino Andreatta and Prodi were there discussing with Professor Onofri. They were discussing forecast from the model. And after that session, I said two things. First, this is something like, say, 3 courses of macroeconomics. And second, say, this is a very Bayesian way to go, because they know a priori exactly what should happen. But because you are into, I say to my student, you have to be into the groove, you have to be into the subject, and that is really important. So let me say, I don't want to be, we study, we do many techniques, blah, blah, but the human factor is still a crucial ingredient in making forecast. And from my point of view, the problem, maybe we come back on problem of forecasting instability, is kind of mixing, say, forecasts provided by structural models, because if I to do forecast, I would never abandon a structural model, because sometimes you need to do, say, counterfactual exercises. So what happens, I was talking before with my friends in Germany, they have been discussing quite a lot using models. Say, what happens if we stop importing gas from Russia, and what will be the consequence on the economy? And they were discussing that on TV by mentioning models, something that, I mean, it's almost impossible here in Italy. It's unbelievable. And of course, a structural model must be the crucial support, but of course we have new wonderful techniques in say, machine learning methods, for instance, using vector autoregressive regressive model with time varying parameter, where we can take into account, say, the volatility of the shock. We have to compute confidence interval for our forecast in the presence of very large shock. And methods, say, more data-oriented are, from this point of view, are crucial, but I think that combining these two ways to go is something that we have to keep in mind in forecasting. And that's what I say always to my student. I teach, say, something on forecasting financial markets. Say, guys, no way, don't forget about forecasting financial market. Maybe we can make forecasts about, say, the volatility, because we teach these models, Arch, Garch, blah, blah, blah. But you have to be an expert of the phenomenon you're forecasting. Okay, so that is my view.
Thank you, Luca. It's interesting that you mentioned that it's hopeless to forecast financial markets, because, I mean, now we can see that economists are taking many of the concepts that we learn in financial economics and financial econometrics, like, for instance, tail risk. Until a few years ago, who cared about tail risk? I mean, the standard deviation was more than enough. The normal distribution was fine. And now we see that concept like value at risk, expected shortfalls. I mean, economists are using this. Value at risk applied to growth. I mean, 10 years ago, this would be like, someone who took LSD and made some mess. And now, I mean, papers in American Economic Review, in top economics journals are based on financial concept. And you mentioned, you are an expert of stochastic volatility applied to macro models, and you're the expert. So one of these, okay, in that strand of literature, economists are incorporating stochastic volatility models to better match the data. But the stochastic volatility process is almost exogenous. So at the end of the day, we don't learn, or we are not interested to learn what moves volatility. I mean, volatility has like an autoregressive structure. We know it depends sort of what happened yesterday, but what are the sources of changes in volatility? So I wonder if you think that in the future, one of the steps could be to model the volatility in a more structural way, and so that we learn how volatility why it changes and how it interacts with the other variables. So,
yeah, well, yeah, you're right. On the first part as well. Yeah, I mean, I think that, as you said, most of models that are around, they just assume that volatility is like an exogenous process. I mean, even if you think of Arch or Garch, they are all exogenous. So going back to your original question, your point about tail risk and stuff, I mean, the interesting thing is precisely that maybe, some people might be not interested in necessarily having an explanation of, why volatility should be endogenous or exogenous, but it turns out that it's actually important also in terms of these asymmetries that we observe and this tail risk stuff and so on. Because imagine that you have, so there is basically two layers to your question. The first is, why do we have exogenous stochastic volatilities? Do we want endogenous ones? But I would split this in two parts. The first part is why, when we model volatility, we only look at the conditional variance. So the first step would be, to take the volatility and understand that this variable that is basically changing, the variance of the shocks can also influence the conditional mean of our process. Okay, so if you think of a Garchi mean, that has been done many, many times, and then already when you do this, you have one step. And then the second step is that, of course, volatility can be influenced by macroeconomic variables, which means that, if there is an increase in volatility, maybe macro variables, they don't go very well, and that causes ulterior change in volatility. So what happens is that once you do this step, you actually are able to explain a lot of the tail risk movement, a lot of the asymmetric downside risk that now, tons of paper coming out with this thing. And, they started with quantile regression and they documented this change. That is like basically this asymmetry in the tail risk movements, but that you can basically explain if you have a good model of volatility. So if you endogenize volatility, you can have something like that, because if you have a shock that increases or decreases volatility and it just moves the variance of your disturbance process, then you're gonna have asymmetric behavior, right? But if your volatility goes in the mean of your model and your model goes in the volatility, so it actually amplifies. I think what you have is that when the variance increases, the mean of your model shifts. And so when you go to the mixing of when you mix the periods with low volatility and periods of high volatility, the periods of high volatility will also be characterized not only by larger volatility, but also by a different mean. And so when you go and mix together periods of low volatility and high volatility, you also mix period with different means, so you end up having an asymmetric distribution. And so this mechanism is further amplified by the endogeneity, and so it can explain a lot of the interest that has been, not the interest, no, can explain a lot of the movements that has sparked this interest. So I think it is key to do that. So, yeah.
And this, of course, is also related to uncertainty in general, right?
But yeah.
How to incorporate uncertainty. And we have an expert of uncertainty here.
Define uncertainty.
Yeah. What are what's the role of modeling uncertainty in forecasting?
Uncertainty is, I have to say, it's a topic in fashion in the last years, because it has been proved that, especially for the U.S. economy, that, say, it is one of the major drivers of the U.S. economy. But the issue is whether, say, uncertainty is an exogenous driver or rather it is an endogenous response to other type of shocks. That is, I think, a crucial issue. And also answering your question on how to incorporate uncertainty in forecasting also depends very much on whether you can answer that. And I've been working on that, for instance, with some friends and colleagues at the University of Bologna, and we the issue is related also to volatility, but in the sense that we have been working, say, in trying to find a connection between, say, volatility regimes and uncertainty. Let me make an example, say, a narrative which regards almost of, say, not only the US, it starts from the US, but not only the US, is that, you know, say, during the 60s, 70s, until, say, the first 80s, we have this period which is called like the Great Inflation. No, we have a situation where stagflation, we have high inflation, the economy is not doing well, blah blah. And after, say, the appointment of Volcker at the central bank, we have this period up to the known as the Great Moderation, up to the global financial crisis. And of course, uncertainty, you have, say, uncertainty in something on the Great Inflation period, uncertainty in something on the Great Moderation period, and after the global financial crisis, uncertainty becomes global financial crisis. Then we have very slow recovery, and then we have pandemic and wars, blah blah. So uncertainty will be incorporating, say, uncertainty will be an important issue, but I think we have to understand whether what is uncertainty. We can measure uncertainty. We have many indexes of financial, macroeconomic, political. I've seen index of geopolitical uncertainty, blah, blah, blah. The point is that we have to incorporate in structural models. And so one of the things we want to understand is whether uncertainty is an endogenous response to other type of shocks. There are many theories on that, and also Andrea has been working on that. I've been working on that. There is not a unique conclusion on that, and that's one of the point. I mean, say forecasting. You can forecast the variable you are interested in by, say, a reducer form model. If you want to do that with a structural model, because I stick to the point that we do need structural relationship in order to understand what's going on. I think that that is an issue that we have to address empirically. And if, for instance, we are able, in our contribution, we saw that, say, uncertainty is exogenous across, say, the Great Moderation, the Great Inflation, the Great Moderation, and the Great Inflation. So in that case, you can incorporate that information in a different way rather than you find that it is an endogenous driver and endogenous response to other type of shocks. And honestly, I would not know how to model that, how to incorporate in a say, fully specified, for instance, DSG model. That is a very important issue.
Okay, you gave a very nice structural perspective on this. But Rob, you are working with forecasting in macro models, and you are working on a model for the Italian economy, and you are also an expert of say, the statistics of uncertainty, so how to construct uncertainty indexes and so on. So I'm curious to know, are these indexes or measures of uncertainty something that you use when you construct a forecasting macro model, or not?
Yes, basically we have so many measures of uncertainty, and of course even for Italy, or in particular for Italy, the big problem is that time series for Italy are not enough long. I know my case. If you use Google Trend, you start in 2004. While if you move in the field of, if you work in the field of the hybrid models, the point is to have enough long information to make the data tell you about the relevance of these facts. So in principle, when you use an hybrid model, you use measures. You base your estimations on measures, and then you start from a single equation estimates, then you start to assess the long-run properties, and so make a forecast to 2050 that probably I will not reach. And this time, so a long-term forecast, and to better understand the statistical properties of your model. And the issue of uncertainty can be taken in the same way. I can try to look at what is the relevance of uncertainty in explaining the effects on investments, on consumption, on labor hoarding, and so make some counterfactual exercise where I can take the model, the baseline solution, and to ask what happens if the uncertainties has a jump up, downwards on the 1/5 of what happened at the COVID period, just in order to understand what is the effect of uncertainty. On the other side, if you have a model, you can also use the model to make uncertainty, in the sense to make a measure of uncertainty. There are a lot, the Serenang experience is about to use this sort of ex-post uncertainty that emerges from the variance of the root mean square error. So for the uncertainty is related with the variability of the forecast errors. And in the same way, if you have a model, you can, in principle, to make some sort of bootstrap of stochastic simulation in order to give the idea of the confidence interval. But of course, in any case, the point with the hybrid model is that of the measure, while the point probably in the SG model is about the variance of the shocks. And so you have just to think about a structure that is able to explain through shocks with given a certain persistence and the amount of the shocks to understand what is the channel of transmission along the cycle of the uncertainty.
Thank you, Rob. Very interesting. I want to change a little bit the focus, because, I mean, the good old times, people were talking about concepts like non-stationarity, co-integration, and which are not really on fashion right now. I mean, I was reading a page of the famous book, Mostly Harmless Econometrics, which should be banned by all universities. and they say, well, serial correlation used to be somebody else's problem, a problem only for the unfortunate souls who made their living out of time series. Okay, like us, exactly. So, but again, when you go to the practice, to the real life, and you need to do forecast, you have to face very simple question like, should I forecast the levels, the first differences? And so, I mean, what would be your suggestion or your approach? Because that's what you have to do in practice. Andrea.
Well, I mean, my rule of thumb in this case would be to only and exclusively use the levels, and because this is something that is probably not. I realized over the years in which I visited, many different, places where people were making forecasts. And I realized that there is perhaps in the UK, maybe there is a UK fixed effect, but there is a very, very large tendency of, whenever there is sometimes serious that is, persistent, something like that, there's a tendency of immediately differentiate it. To the point that I've seen cases that you don't actually, sometimes they don't even have the variable in levels on file. And that is surprising because, we know since the 90s, several papers. The most famous one is Sims, Stock and Watson, Econometrica, 1990, in which, they strongly make a point that, of course, unit roots are a problem, but, you don't have to routinely just take first difference and forget about it, because if you do that, you lose any information, any possible co-integration relationship that is there. And, there is plenty of evidence that that's not a good idea to do. And, there is a lot of, I found again, there is a lot of confusion about this. And, in practice, it's a bit like imposing a restriction, right? When you differentiate the data, you're basically saying that there is no co-integration there and that you forget about it. And if this restriction is not satisfied, then your forecasts are gonna take the hit. This is just, so this is like my experience. I have quite a lot of experience in forecasting, I must say, US data. And for those data, though, there is like a clear indication that you should always use the levels. There are, of course, cases in which you might want to use the differences if there is maybe a big structural change. That could be one case. But besides that, my suggestion would be to use levels. Because, the data, if the data is not stationary, the OLS is going to pick that up at a speed that is actually faster than if it wasn't stationary.
Rob, Luca, anything to add on this?
Of course, my answer is obvious, given my job, levels all the life, and in particular, I would say something that to give you my view about the not co-integration done. Co-integration is a useful concept. Co-integration test is not probably as good as the concept of co-integration. So instead of working with a number of fixed rules, better if you must, because you always, I agree with, you always must use levels. If this level does not co-integrate, there must be a reason, in the sense that we are not comparing the Anglican wedding with the number of homicides. So it's not a spurious regression. What we are trying, storks and natality. We are putting together wages and unemployment rate. So if there is not co-integration in this context, there must be either a theoretical problem, because probably in this case you should need, instead of a wage curve on level, a growth rate of wage in the sense of the Phillips curve, or easier, given that we need to use data. Of course, in my view, the data are telling you something that the armless econometrics never tell you, because the no co-integration means you are excluding some relevant explanatory variable, possibly also latent. And in this way, you can change your failure in finding some textbook relationship with the opportunity of having some clear indication of what you are missing. Your model is missing, this equation is missing, and try to improve the quality of your model. When you work in the armless econometrics field, you don't have this power that is not co-integration, unit roots, lack of long-run relationships where the consensus theory would like to have a sort of long-run equilibrium or steady state or something like that. Good. Probably either your data are really wrong, but nowadays, so get rid of the oldest one, probably because they were made by me when you worked in Promethea. But the most recent data filtered with input-output tables and checked in the appropriate account of the economic situation are telling you implicitly you are omitting something. So levels plus the openness of mind to change the specification of the long-run relationship of your model in order to find the level relationships independently on what. First difference means to get rid of the model with the problem, because of course, if you are thinking about macroeconometric modeling.
Yes, thank you, Rob. And Luca, you want to add something? Or?
Well, it's a very subtle issue. I would say that there are two different levels. One is if you have to identify, say, if you're using, say, a VR model and you want to identify structural shocks, you can use the standard practice to use level, just forget about co-integration. So the question I get from my student who attended Professor Cavaliere pre-course is, okay, but say we should impose co-integration, otherwise when we compute impulse response function and we build, say, confidence interval for confident interval, which are the final, say, object of interest. We want to measure the impact of some structural shocks on variables, and we want to have we have to make inference on the uncertainty surrounding these estimates. And econometric theory says that you should impose, if you have unit roots in a model. Once you go, it's right. Andrea was right mentioning that there is an important results by econometrician that say you can estimate your model by OLS and you get your OLS is still fine. But once you move to the moving average representation and so you have to compute, say, confidence interval for the impact of the shocks, of course, the theory changes completely. But typically we forget about that. We don't care about that. The US econometricians, but not all US econometricians, every econometrician just forget about that. You can, but the point is that you can impose co-integration. You can impose unit roots if you want to do that. I imagine that one reason why we tend to ignore the issue is that you don't get very sensible gains in forecast. If you go in forecasting, if you compute practically forecast, but also say in quantification of the impact of the shock. One say I recommend when it is possible in order to, because of course we have to go for level. We cannot discard the information provided by the levels of the variable and just focus on growth rates because growth rates are stationary. We all know that, but sometimes we have tricks. We can little bit manipulate our variable, our model, such that at the end of the day you are modeling jointly both growth rates on variables and say combination of levels. That's something that I typically recommend to Professor Cavaliere students when they come to me and say, well, I've been working so long time on co-integration, blah, blah, blah. Now we have to identify shocks. You say nothing. You say nothing about that. So why are you silent on that? And it's so this year I decided to also to take a stand on that. Okay, I will. We can do that, but it is more from a technical point of view. It's little bit more. I would not say complicated. A little bit more involving, but it's not rewarding. It's not as rewarding as we would expect. That is a very practical explanation of why we don't do it.
So it's a compromise solution where essentially you are adding the co-integrating relation into your model, right?
I would add, yes.
Plus the co-integration.
Yes, but you know, if you have to publish if you have to forecast K, but you have to publish your result, you better hide the co-integration. Yeah, it's like that. I know it's not beautiful what I'm saying, but you can. One way to do that is say manipulating. Say the famous vector error correction is just a way you can rewrite it such that nobody recognized that you are imposing co-integration. I did it several times. I have to say. Yeah.
Okay. To the juniors, you can take notes about this.
The co-integration police.
Yeah. And final point, from the econometrics perspective, what we saw today also was a lot of a robust estimation method. It's like people out there, recognize that we have extreme events fat tails and OLS makes no sense, okay? I mean, when I talk to people, statisticians doing time series for variance with, time series analysis for data with fat tails, they always say, well, why you care about OLS? I mean, makes no sense. And then my only reply is, yeah, but economists understand OLS. I cannot use something more difficult. And
Politically.
Yeah, exactly. But today, I mean, we have seen that they are taking over, they are using techniques that at the end of the day are robust estimation. Okay, even if you do OLS plus dummy variables, that's a robust estimation. It's called a Huber estimation. And Bayesian methods allowing for T distributed errors is again robust estimation. I mean, you are robust to outlying events. So my question is there a hope to that the idea that the harmless OLS estimator at the end of the day is not as useful as some people want to believe, especially on the other side of the ocean?
Of course, in the sense that probably, I don't know, but in the logic of a macroeconometric model, OLS can be done only if explanatory variables are weak exogenous. And it's not enough the Johansen weak exogeneity, because that exogeneity is about the inference in the long run. But you also need that the shocks, or better, the errors in the context of a hybrid model, covariance must be zero, and this in many cases is not true. So some equally traditional approaches like GMM or two stages least squares with some way to make and to use to assume valid instruments from the structure, the same structure of the model, is a first point. So OLS in this context are not the best way. Then also, like OLS, also instrumental variables or GMM are affected by location shift, outliers, COVID effects. And in this context, again, from the point of view of macro modeling, I think that is revealing what Massimiliano told this morning. So, of course, we can robustify, we can weight, we can use alternative way to account in the estimation phase. But if you make a forecast by using a macro model, you have to account that from the use of the dummy to just get rid of the observation, or something more robust, when you will forecast the next 3 quarters, you will have error correction, equilibrium adjustment that will tend to revert from a starting point that probably is mislocated. So when you make a forecast and you ideally need a dummy to give you some reasonable initial conditions, you probably need the dummy also for the future. So when you would need dummies or downweight the latest observations, remember that you can downweight this observation in the phase of estimate. So we probably have more efficient estimates of the parameters. But when you start your simulation, you start from big T, and big T is there below, and this can give you some strange dynamics. And if you need dummy for the futures, probably you need add factors. That is the word for dummy of the future. And in doing so, of course, the use of high frequency forecast and all information you can get from the new, for example, I wanted to say about the global supply chain pressure index. Now, this could be interesting. So try to use all the information you can get, even in the short period, the weekly model of stocks of the New York Fed, just to have some ideas about the first quarters you have to forecast. Because in any case, you can robustify estimates, but you can't, unfortunately, robustify the starting points.
Thank you, Rob. We are running out of time. Lorenzo, do you have any question for our guests? The macroeconomist question.
Oh my God! So first of all, there is so much food for thought in everything this morning that I will need a week to try to rationalize. Second, I feel lucky I'm not an econometrician, and you know I no, in the sense that I really believe in principles of economics that we could call theory. And the question is that, of course, we don't have a general theory of everything. And so that's the reason why it's difficult. We have partial theories. And that's, we don't have a general model of everything. And we don't have the data, even if we had the general model of everything, to get a reasonable starting point of this general model of everything. So, so this, of course, makes also theory weak in a certain sense. But one point that I was thinking, and maybe you have maybe you have some feedback. I mean, there's been a lot of discussion about volatility, about uncertainty, and which is the second moment. And nobody mentioned ever expectations, which I would the first moment, let's say. And I was wondering whether you have any sense of, you know, in general, after the Great Moderation, if you look at real time series, you see this increase in volatility. Do we know whether there is an increase in the shift in expectations? And you know, there are a lot of data you could use to check that, and I guess it should intuitively, but I don't have evidence. So I'm asking for whether you guys have evidence of the fact that expectations are more volatile, and this actually implies that the business cycle is more volatile somehow. I don't know. Maybe there are other questions from the floor. We should collect them because time is really running. Okay.
Yeah, expectation is a very great point, and I just wanted to reply because I've been working, say, quite a lot on the econometrics of rational expectations. Are they rational? I don't know, but so on the econometrics of model-based expectations. In a sense, think about, for instance, to Francesco, the SG model, and my question was, do you have, say, when you have, say, the point is, as you said, as to account, as to measure for how do you get from expectation? Of course, you can use, say, survey of professional forecaster as a proxy for expectation. It seems that they work quite well. There are many different ways. For instance, we have, say, rational expectation, learning mechanism. Let me say just an anecdote. As a forecaster, I have lost my credibility also with my circle of friends on WhatsApp, because they say a couple of months, say it was January, said, okay, inflation is rising, Professor Fanelli. So what is going to happen? I said, don't panic, because I was working on the New Keynesian Phillips curve in the euro area, and you know there is this story on the slope parameter, and you don't know whether the slope is there or not. I said no, it's just a temporary shock. It's just temporary. Indeed, you can see that the European Central Bank is just moving in a very gradual way. Of course, I cannot predict that Russia was invading Ukraine and it became a mess. Now, every day it says, they send me, say, the exchange rate, US ruble exchange rate, and also inflation is increasing, so you are not credible as an economist, your forecast is completely wrong. So, and one way to go is that, say, also expectations. In the New Keynesian Phillips curve, inflation today depends on what agents will believe it will be future expectation, because firms will fix prices by looking what happens. And one way to account for this expectation in these models also we use typically VR model, vector regression model are kind of way of compute, say, kind of proxying expectation, like, say, conditional forecasts that you get from a model that you believe can somehow approximate the dynamics of your data. And expectation can also be a cause of your model of multiple equilibria, because if the solution of your model is not unique, a mess can happen. For instance, one explanation of the great inflation it was that the DSG model, the Fed had in mind before the 70s was something where, say, a model with multiple solutions. And after Volcker appointment and the fight against inflation, we get stability. So this DSG model have a unique equilibrium because expectation was anchored towards, say, the central bank will control expectation. So modeling expectation is part of the structural modeling of your. But you can proxy with survey. It seems that works in a satisfactory way.
So Giuseppe will propose also for the people remotely to close this up.
Yes.
And then we can keep going actually for a little while, maybe informally.
Okay.
I mean.
So thank you for being here, and thank you for our wonderful guests. And bye-bye, and hope to see you again in another event like this one.